When astronomers first spotted the object they designated Tri/A, the details seemed fairly straightforward. A small point of light captured by a survey telescope in Chile, just another piece of data in the daily routine of scanning the sky.
But soon, what had seemed ordinary began to morph into something unprecedented. Calculations of its orbit revealed a hyperbolic trajectory, the unmistakable sign of an interstellar visitor. It was the third time humanity had confirmed the existence of such a wanderer, after the discovery of one Oumuamua in 2017 and two Isofalch in 2019. Yet there was something special about it from the start. Atlas refused to behave like a typical comet or asteroid, leaving scientists questioning not only its composition and origin, but what its arrival might mean for the nature of our universe. In fact, interstellar objects are not impossible. Planetary systems form in chaotic environments where gravitational interactions fling debris into interstellar space. Some of this material, by chance alone, should occasionally cross paths with our solar system. But the first three detections raise questions about how frequent these encounters should be.
For decades, astronomers have predicted that interstellar objects would be rare, perhaps one a century. Yet in less than a decade, three have emerged, each with unusual characteristics.
It's a small statistical sample, but enough to make researchers wonder if there's more at play than random scattering. The first was elongated and oddly reflective. The second looked more like a traditional comet, but still held secrets in its chemistry.
Now comes a third, faster, richer in carbon dioxide, and traceable to a stellar population as old as the Milky Way itself. The question grows more pressing. Why do these visitors keep arriving in ways that defy natural explanation?
And if this third one is not entirely natural, what will that mean for us? From the start, astronomers noted the extreme speed of Tri-ATLs.
Its hyperbolic excess velocity exceeded 60 kilometers per second, much faster than most interstellar objects should be moving if they were ejected by normal planetary interactions. The fact that each successive object we detected arrived faster than the last pushes the boundaries of coincidence.
Are we simply seeing an upper limit on the velocity distribution? Or is there a pattern? Patterns in astronomy often signal hidden mechanisms, and hidden mechanisms sometimes lead to disturbing conclusions. But speed alone is not what sets this visitor apart.
Its spectral analyses revealed chemical signatures unlike anything in our solar system. The James Webb Space Telescope detected unusually high ratios of carbon dioxide to water vapor, on a scale unprecedented in cometary science.
Such chemistry suggests formation in conditions very different from those around our Sun, perhaps in a region of the protoplanetary disk where carbon dioxide was dominant and water ice was scarce. Still, the timing of its activity seemed suspicious.
At distances where most comets remain quiet, Atlas was already active, blasting gas into space with an energy that raised more questions than it answered. Astronomers naturally gravitated toward conservative explanations.
Radiation processing, exposure to cosmic rays over billions of years, the possibility of insulating layers of dust, protecting the water ice and allowing the carbon dioxide to escape. Each explanation has some merit, but none seems complete, and so speculation begins.
Because speculation fills in the gaps where observation fails. Could this object be engineered to appear comet-like, yet harbor systems we cannot detect? Could its unusual composition be a deliberate feature designed to disguise its true nature as natural variability?
The problem with dismissing such ideas is that history repeatedly shows how nature produces phenomena that mimic intention. Pulsars, fast radio bursts, quasars all once seemed suspiciously artificial, until further evidence revealed natural processes stranger than we could have imagined.
But the reverse lesson is also true. When the evidence doesn't fit existing theories, the possibility of design can't be ruled out entirely. A thought experiment arises. What if the visitor we're observing isn't random junk, but a reconnaissance device disguised as commentary material?
The point is that we're unable to detect the presence of intelligence operating on scales beyond our reach. Consider the cloaking hypothesis. If a civilization wanted to observe evolving species in distant star systems without being detected, what better strategy than to mimic the most common natural interstellar visitors? Comets and asteroids number in the trillions. Their passages cause no alarm.
But if one were designed to carry instruments, it could slip past countless civilizations undetected, collecting information while blending into the cosmic background noise. The discovery of the 3I Atlas objects invites us to consider this possibility.
Not because the evidence supports it, but because the consequences of ignoring it would represent a worst-case scenario. What if this visitor doesn't leave? The math shows a hyperbolic escape trajectory, but trajectories can be altered by subtle forces we can't measure over vast distances. The idea that Atlas could use the flyby to slow down rather than speed up may sound like science fiction, but slowing down is exactly what any probe would need to linger in the system. The faint plume of gas, misinterpreted as a comet from outgassing, could actually be controlled movement. Anomalies too subtle for today's telescopes to detect could hide deliberate maneuvers. And if its path changes in ways we can't predict, how long will it take us to notice? There's also the question of its origin.
Tracking its velocity vector places its source not in the galaxy's orderly thin disk, where most of the stars and planets reside, but in the thick disk, a population of stars that formed billions of years earlier.
That makes Atlas potentially older than our solar system, a relic from a time before Earth existed. If it's just natural debris, it's a geological artifact, unknowable, carrying a chemical record of the galaxy's birth. But if it is something more, then we are witnessing the arrival of technology developed by a civilization that predates humanity by billions of years. The implications of this possibility are staggering. Even if it is natural, its survival is questionable.
Small objects should not remain intact during billions of years of interstellar travel. High-speed collisions with dust particles should destroy them. Radiation should gradually alter their surfaces until volatile activity becomes impossible. Yet Atlas arrived energetic, active, and massive enough to generate a coma visible at astronomical distances. How does something so fragile survive for so long? Natural explanations are unsatisfactory. Speculative ones suggest durability born of design rather than chance. Our instruments report silence. No radio transmissions, no coherent signals, no thermal anomalies. Every dataset confirms the natural hypothesis. Yet absence of evidence is not evidence of absence, especially when we are dealing with potential intelligence orders of magnitude more advanced than our own. A probe designed to remain hidden will not broadcast in a way we could detect. It will emit only what we would expect to see from natural processes. A respect for the silence of the electromagnetic spectrum and the apparent laws of celestial mechanics.
Its very silence may be a sign of success. This leads to a paradox. The more convincingly natural the ATO appears, the more effective it will be as an engineering device. If we dismiss the possibility of intent simply because it behaves like a comet, we close our eyes to the prospect of an intelligence advanced enough to master the art of camouflage. And if such an intelligence exists, TL's arrival may not be a coincidence.
It may be a deliberate encounter, calculated for reasons we cannot yet understand. For now, humanity is watching. Telescopes around the world and in orbit continue to collect data, feeding it into models that again and again confirm the natural interpretation.
But the shadows of speculation remain. What if the data we trust is precisely what we were meant to see? What if we are studying not a visitor from the stars, but an emissary meant to observe us?
The line between natural and artificial blurs as the stakes rise, and the worst-case scenario is not impact, not destruction, but observation. To be observed without understanding by a presence beyond our comprehension may be the most disturbing outcome of all.
From the very first orbital calculations, the numbers surrounding the three-eyed Atlas object seemed quietly menacing. Objects in space move at tremendous speeds by human standards, but their speeds are generally within known limits, imposed by the gravity well that formed them.
Asteroids bound to the Sun describe elliptical trajectories at speeds that rarely exceed a few dozen kilometers per second. Comets, accelerating toward the Sun from the outer solar system, can reach speeds of more than 50 kilometers per second near perihelion, but always return to the long, slow arcs that brought them here.
Hyperbolic interstellar visitors, on the other hand, are different. They arrive carrying the momentum of other star systems. Their paths are open, their destinies unbound. When a third such object arrives, the difference becomes impossible to ignore. Its hyperbolic excess velocity of over 60 kilometers per second makes it one of the fastest natural objects ever observed in our neighborhood. To put that into perspective, 60 kilometers per second means that every second the object travels farther than most commercial airliners travel in a full minute.
In 1 hour, it travels over 200,000 kilometers, nearly half the distance from Earth to the Moon. In 1 day, it zooms through more than 5 million kilometers of space. Compared to earthly experience, these numbers are meaningless.
Even compared to other space wanderers, Atlas seems to be moving with unreasonable haste. Oumuamua entered our system at about 26 kilometers per second. Borisov was moving at about 32 kilometers per second. This third visitor is double the speed of both of its predecessors, suggesting that the speeds we encounter are becoming more extreme with each new detection.
Coincidence can't be ruled out, but neither can the possibility that these increasing velocities hint at something more than chance. When scientists modeled the dispersal of small bodies during planetary system formation, they find that typical ejection velocities are in the range of a few kilometers per second.
To reach more than 60 kilometers per second requires extraordinary events, close encounters with giant planets in unstable systems, strong interactions between multiple bodies, or ejections from binary star systems where gravitational slingshots impart enormous energies.
Any of these explanations is plausible, but each becomes increasingly difficult to reconcile with the picture of what we've already observed. How many times can we attribute unusual interstellar arrivals to extraordinary coincidences before we begin to wonder whether something else is shaping their trajectories?
The faster an object, the shorter our window to study it. Speed robs us of opportunity. By the time telescopes zeroed in on Atlas, it was already closing in, crossing millions of kilometers a day, its perihelion date set and approaching with inexorable certainty.
Unlike planets and asteroids, whose motions allow us to make predictions years or centuries into the future, these interstellar visitors offer only fleeting glimpses. Oumuamua was discovered after it had passed closest to Earth, leaving us chasing a receding mystery.
Borisov gave us more time, showing off its cometary tail as it flew through the inner solar system. Atlas occupies an in-between position, bright enough to study, but too fast to linger. The pace of its passage forces us to accelerate science.
Telescopes around the world race to gather as much data as possible before it disappears forever into the depths of space. The physics of such speed complicates speculation. At over 60 kilometers per second, Atlas cannot be captured by the Sun. Its trajectory is hyperbolic, meaning it will not return. The math seems precise, but the speculative mind notices something else. Such a speed is also optimal for reconnaissance.
Too fast to be captured, too swift to be intercepted by our spacecraft. Its trajectory ensures both escape and safety. A civilization deploying cloaked probes would likely choose speeds that maximize data collection, while minimizing the risk of detection or interference.
From our perspective, the object appears to be a harmless natural comet. From another perspective, it could be an ideal scout, skimming past planets, sampling radiation and emissions, observing without consequence, before continuing its endless journey. High speed also ensures longevity.
Collisions with interstellar dust particles, while devastating over billions of years, become less significant if travel time is shortened by speed. A probe traveling twice as fast spends half as much time exposed to the hazards of deep space, increasing its chances of survival.
Perhaps Atlas moves fast, not by accident, but by necessity. Perhaps the civilizations that built it, if they exist at all, understood that time itself destroys even the most robust technology.
If the object is artificial, then its incredible speed is not an accident, but a design decision. However, the speed raises other questions. Could Atlas have been deliberately accelerated?
Our own species has begun to experiment with the concept of light sails, thin sheets propelled by radiation pressure or focused lasers. In principle, such technology could accelerate small probes to interstellar speeds exceeding those of natural emissions.
If even a technologically young civilization like ours can imagine this, more advanced civilizations must have mastered it long ago. The question becomes vexing. Are we witnessing the passage of an object accelerated through the galaxy by an intelligence, disguised as a comet?
If so, its speed is not evidence of chaos, but of precision. Astronomers, cautious by nature, resist these ideas. The conservative explanation remains this simple.
A small, icy body ejected from its home star system in the chaotic early years, drifting for billions of years until chance delivered it to our doorstep. The speed itself, however, challenges this narrative.
Computer models predict that interstellar visitors should arrive in numbers consistent with random ejections, but at speeds somewhat slower than those we observe. Are we just unlucky to see 3 unusually fast objects in a row, or is there some unrecognized mechanism at work?
One possibility involves galactic dynamics. The thick disk population from which Atlas appears to originate is made up of stars moving at different speeds relative to the Sun.
If the object originated in this older population, its unusual speed might reflect differences in galactic motion rather than unusual ejection conditions. But even this explanation is troubling.
If Atlas has been wandering since the Milky Way's youth, it has survived eras when the stars were more violent, collisions were frequent, and radiation more intense. How has it survived?
The faster it moves, the less time it has to decay. But billions of years remain billions of years. Its persistence seems unreasonable. In purely practical terms, Atlas's speed means that no spacecraft we possess could catch it.
Even if we launched it upon detection, the delta V required to intercept it exceeds the capabilities of any current propulsion system. By the time the mission is designed, tested, and launched, the visitor will have long since vanished.
This asymmetry underscores humanity's helplessness when confronted with interstellar mysteries. We observe, we speculate, but we cannot interact. Speed shields an object from us as effectively as distance or cloaking. The numbers themselves carry weight.
At 130,000 miles per hour relative to the Sun, Atlas crosses the continental United States in less than 3 minutes. In the time it takes to read this sentence, it has traveled tens of kilometers.
Its hyperbolic excess velocity of 61 kilometers per second ensures that even the Sun cannot slow it down enough to keep it from moving. Gravity bends its path, but cannot bind it.
We are left with only a brief glimpse, a cosmic flyby too fast for comfort. Yet, speculation thrives in such circumstances. What if the velocity profile is not purely gravitational?
What if Atlas is shedding mass in ways that mimic cometary activity, but are tuned to maintain or change velocity for a specific purpose? Outgassing produces non-gravitational accelerations, and comets often deviate from purely gravitational predictions.
But these deviations are chaotic due to heating, rotation, and sublimation. If Atlas shows systematic deviations instead, subtle but measurable, it might indicate motion disguised as natural processes. Current data show no such anomalies, but detection thresholds matter.
The difference between natural outgassing and controlled thrust may be invisible on interstellar scales. There is also a psychological effect of such speed. Humans are instinctively uneasy with uncontrolled, fast-moving objects, especially when they come from outside.
We measure threats not only in terms of collision probability, but also in terms of unpredictability. An object moving so fast, immune to capture, indifferent to our attempts to intercept, seems threatening. Even if it poses no risk of collision, it triggers a primal reaction.
Something powerful has entered our sphere, something beyond our control. Official assurances from NASA and ESA emphasize safety and scientific value, but behind the calm language lies an unspoken truth. Our helplessness is absolute.
If Atlas were to change course, we would be powerless to do anything. If it were to release smaller objects, we would be powerless to stop them. If it was simply to continue on its way, we would be spectators, unable to influence its trajectory.
Its speed is not just a number. It is the barrier separating us from the ability to act. We watch because watching is all we can do. This awareness shapes the worst-case scenarios.
The most frightening aspect of Atlas may not be what it is, but how fast it is moving. The pace of its travel robs us of time to prepare, analyze, and respond.
If it were a messenger, we would have only months to gather data before it disappears. If it carried hidden systems, they could activate and deactivate before we notice them. Its speed ensures that control lies elsewhere, not with us.
To a species accustomed to studying the skies with patience and precision, this seems deeply unnatural. The cosmos usually unfolds slowly. Stars evolve over millions of years. Planets rotate in predictable rhythms. But Atlas does not wait.
It rushes past, demanding urgency from creatures unaccustomed to such haste. We must acknowledge that speed is part of the puzzle. Whether natural or artificial, accidental or deliberate, it determines everything about our interactions with this visitor.
It is why we cannot intercept it, why we cannot contain it, why we cannot confirm or deny speculative scenarios with certainty. It ensures that this event is temporary and irreversible.
By the time humanity has reached the technological maturity to intercept such objects, Atlas will have vanished, carrying its secrets into the interstellar night. All that remains is data, fragments of spectra, images of a faint coma, orbital features plotted on maps, all filtered through the velocity distortion.
A visitor that should not exist is moving at a speed beyond reason, and that speed guarantees her ignorance. It leaves us in the uncomfortable position of wondering whether our instruments are reflecting truth or illusion.
Perhaps it is just a comet, accelerated by cosmic chance. Perhaps it is something more. We cannot know. What we do know is that it is moving too fast for answers.
And as it hurtles toward perihelion, our time to ask questions shrinks as surely as its distance from the sun. From the very first Oumuamua images, scientists have faced a familiar problem. When working with comets and interstellar objects, size is never unambiguous. Unlike solid asteroids, whose shapes can often be measured directly from reflected light curves, comets shroud themselves in comas, diffuse clouds of gas and dust that extend thousands of kilometers beyond their nuclei. The result is a kind of astronomical cloaking.
The glowing shell reveals activity, but hides the actual body beneath. With Atlas, this cloaking has become especially effective. Estimates range from a few hundred meters across to more than 5 kilometers across. This uncertainty is more than just a minor inconvenience.
It's the difference between a large boulder and a small mountain, between something fragile enough to shatter in interstellar space and something strong enough to withstand billions of years of wandering. The size problem, then, is not simply a matter of measurement.
It's about survival, probability, and the unsettling possibility that the uncertainty itself hides something deliberate. Determining the size of distant objects requires guesswork. Scientists measure the brightness of the coma, subtract out the expected contributions of dust and gas, and apply models of the albedo, the reflectivity of the underlying surface.
A darker surface yields a larger nucleus for the same apparent brightness, while a highly reflective surface suggests something smaller. But Atlas complicates the process. Its unusual chemical composition means that its outflow rates don't match typical cometary patterns.
The dominance of carbon dioxide, as revealed by the James Webb Space Telescope, suggests a composition far from normal, raising doubts about whether conventional cometary models apply at all.
If the coma is brighter than expected because CO2 is expelled more efficiently than water, the nucleus could be much smaller than current estimates. If, however, the coma hides a much larger core, isolated by a processed crust, then our numbers may be underestimating.
Either scenario leaves us searching for certainty that refuses to arrive. Smaller objects should not survive interstellar journeys lasting billions of years. The news outlet presents an analysis of the unusual characteristics of Comet Atlas, which challenge conventional astrophysical models.
The comet's nucleus, only a few hundred meters in size, would be extremely vulnerable to the destructive effects of tidal forces during its ejection from the parent star system.
Moreover, it would be easily destroyed by collisions with cosmic dust particles, each of which would release colossal energy at relative speeds of up to tens of kilometers per second. Over geological epochs, even the tenuous interstellar medium should gradually destroy such a small body.
Radiation exposure would evaporate the volatiles, leaving behind only an inert rock drifting lifelessly through space. However, Atlas is active, ejecting gas into space in quantities sufficient to be detected at astronomical distances.
If the comet's nucleus is really that small, its very survival becomes inexplicable. Something must have protected it, or something must have renewed it. Either explanation flies in the face of our natural expectations.
A larger core, perhaps several kilometers across, solves the survival problem but creates another. Large bodies are much less likely to be ejected from their solar systems. The mechanics of gravitational slingshots typically favor the ejection of smaller debris.
A massive body has greater inertia, requiring more powerful collisions to eject it into interstellar space. The fact that Atlas can be both large and ancient flies in the face of statistical expectations. Have we just stumbled upon an unlikely survivor?
Or are we observing an object that was designed to be larger than necessary precisely to survive? If this is indeed a probe disguised as a comet, the larger size provides storage space for systems, shielding for sensitive instruments, and redundancy in the event of cosmic impact.
The size problem begins to look less like a measurement problem and more like a potential clue. The scenario under consideration raises questions about the likelihood of detecting extraterrestrial technology and how we can interpret the data obtained by observing celestial bodies. Reflections on the purpose of creating such a probe and its potential tasks may lead to new directions in astronomical research and to a rethinking of existing hypotheses about extraterrestrial life. There is another aspect to this mystery. Comets change in brightness as they rotate.
By analyzing the variations in their light curves, astronomers can estimate their rotation periods and infer their shape. But Atlas has remained remarkably constant, at least for now. This stability complicates rotation models.
Either it is rotating in such a way as to produce a nearly symmetrical output, or the coma is masking the variations. If the comet is small, we should expect more dramatic changes as different parts of the surface sublimate.
If it is large, the rotation should still leave subtle traces. The fact that we see neither raises the suspicion that we're missing something.
A probe designed to mimic cometary behavior would need to carefully manage its output, giving the appearance of randomness while hiding deliberate changes. Atlas's remarkably stable brightness could be just a natural coincidence, but it also fits the requirements for effective cloaking all too well.
The question of size is directly related to survival over time. A comet nucleus just half a kilometer wide should not contain enough volatiles to remain active after billions of years. Even a larger nucleus faces challenges. Sublimation depletes reserves.
Cosmic rays alter chemical structures. Impacts erode surfaces. How then does Atlas arrive not only intact, but still active? Some scientists suggest the insulating layers of dust may have sealed the reservoirs, preserving reserves of volatiles until the sun's heat released them.
Others suggest that cosmic radiation may have altered its chemistry, creating layers that have delayed sublimation until now. Further studies of Atlas's chemical composition and structure may help confirm or refute these hypotheses, as well as reveal new aspects of its unusual behavior.
Analysis of the isotopic composition of the comet's volatiles and minerals could provide valuable information about its origin and evolution. These explanations, while plausible, seem more like excuses than answers.
They plug holes in our understanding rather than explain why this particular object continues to defy expectations. The speculative alternative is more troubling. If Atlas is not just a stray interstellar rock, but something engineered, then its size becomes purposeful. Large enough to survive, small enough to remain undetected, capable of carrying both cloaking and payload.
In such a scenario, the coma is not a natural outgassing but a controlled exhaust designed to mimic cometary signatures while hiding the systems within. The uncertainty on our measurements then becomes not an accident, but the result of deliberate engineering.
By ensuring that any calculation of its true size remains ambiguous, such a craft would maximize its ability to pass itself off as a natural object. We find ourselves measuring exactly what it wants us to measure. Astronomers are reluctant to engage in such speculation.
Still, the size issue raises questions. Even with natural explanations, the object behaves unlike anything else we've studied. Oumuamua was long and thin, tumbling erratically. Borisov looked more like a standard comet, but it had a chemical composition that puzzled researchers.
New data from modern telescopes and analytical techniques may help resolve these discrepancies and bring us closer to understanding the true nature of Comet Deslas. Atlas continues to exhibit anomalous behavior. Each new interstellar visitor forces us to rethink the limits of our models.
How many more anomalies can we encounter before anomalies themselves become the norm? Another complication is comparisons. Within our own solar system, comets vary greatly in size, from a few hundred meters to tens of kilometers.
Their activity also varies accordingly. Larger comets maintain tails for months, while smaller ones are sometimes destroyed by a single close pass. Yet Atlas, with its ambiguous size, seems to maintain an activity level that is incompatible with either extreme.
If it is small, its activity is too high. If it is large, its coma is too weak. It occupies a statistical no-man's land where neither the explanation for small comets nor the explanation for large comets seems adequate.
The numbers are inconsistent, leaving open the troubling possibility that our categories themselves are inadequate. For planetary defense researchers, estimating size is more than an academic exercise. An object 1 kilometer wide could cause planetary-scale damage in the unlikely event of a collision.
An object just a few hundred meters across could devastate a region, but not the entire world. NASA and EA carefully calculate collision probabilities, even when trajectories do not clearly indicate a threat.
With Atlas, numbers matter less in assessing the danger and more in understanding what this visitor actually is. But the inability to pin down those numbers illustrates our limitations. Even with the most advanced telescopes in history, we're left guessing whether this ancient traveler is the size of a mountain or a boulder. And that uncertainty itself becomes part of the mystery. The role of size in worst-case scenarios cannot be overstated.
If Atlas is small but remains intact after billions of years, then our understanding of survival in interstellar space must be reconsidered. That alone would challenge astrophysics at a fundamental level. If it is large, then its very presence near our solar system becomes uncomfortably unlikely. And if that uncertainty itself is evidence of a cover-up, then we may be faced with not just a scientific conundrum, but an existential one. Which outcome is worse?
Realizing that we know far less about cosmic survival than we thought, or realizing that survival was never natural in the first place. When scientists publish their estimates, they do so cautiously, stating ranges and uncertainties, leaving room for revision.
But the public craves certainty, and the media amplify whatever number sounds most dramatic. The truth is less satisfying. We simply don't know how big Atlas is.
This ignorance forces us to confront not only the gaps in our measurement methods, but also the possibility that some mysteries are meant to remain unsolved. The worst-case scenario is not the impact, not the collision, but the ambiguity itself.
The persistent uncertainty about whether we have glimpsed a relic of cosmic history or the product of an intelligence so advanced that it hides its scale behind the glow of its coma.
The size issue, then, is not a technical footnote, but a central theme in understanding this visitor. It makes us question the survival of small bodies, the improbability of large bodies, and the disturbing possibility that the uncertainty itself is a message.
Atlas refuses to reveal its true size, and in this refusal lies the real mystery. As it continues its journey toward perihelion, the coma will become brighter, the core more obscured, and the estimates no closer to agreement. We watch, we calculate, and we guess, but the core remains hidden. Perhaps that is by design. When we call one Oumuamua an interstellar object, we mean more than a visitor from another star. We mean a survivor. The galaxy is not gentle.
It is a place where collisions, gravitational tides, radiation storms, and cosmic catastrophes rule for billions of years. Most small bodies never live long enough to tell their stories.
They're destroyed, dispersed, or vaporized in the heat of the stars and the violence of collisions. Yet Atlas arrives folded, still carrying volatiles, still active, as if it had defied every destructive force the Milky Way had thrown at it over the eons.
The very fact of its arrival begs for an explanation, because survival in a galaxy so hostile is never guaranteed. Atlas's putative thick disk origins make the puzzle even more pressing. This population of stars is old, dating back 10 to 12 billion years. During the Milky Way's early days, when the galaxy was chaotic and wildly active, star formation was characterized by turbulence, collisions, mergers, and intense radiation fields. If the object called Atlas is indeed from that era, it has endured conditions that no other known body in the solar system has ever encountered. That means it predates the Earth, the Sun, and all the planets that orbit it. It also means it has been traveling longer than complex life has existed on our planet. For an object that old to be intact, still emitting gas, and bright enough to be seen with telescopes, it challenges the limits of what natural survival allows. It's important to consider what interstellar travel entails. The space between the stars is not empty.
Dust grains and individual atoms lurk in every cubic centimeter. At the speeds Atlas moves, colliding with even a microscopic particle is like being constantly bombarded with bullets.
Over millions of years, such collisions erode surfaces, chip away at structures, and gradually grind objects into tiny pieces. Over billions of years, the erosion would be severe enough to reduce small comets to rubble. Radiation compounds the problem.
Cosmic rays, high-energy particles that streak through the galaxy, continually pound surfaces, breaking apart molecules, altering chemistry, and creating crusts of altered material that trap volatiles.
For an object to remain active after such an impact, it would have to be either unusually large, unusually strong, or protected in ways we don't understand. There are natural explanations, though each has its limitations.
One is that Atlas formed with an unusually thick reservoir of volatiles. Deep layers of carbon dioxide and water ice are buried beneath protective crusts. Over time, radiation may have further sealed the surface, trapping the gas until the sun's heat penetrated new layers.
Another possibility is that Atlas spent most of its journey in relatively quiet regions of interstellar space, away from high-density dust lanes or supernova explosion zones. But even the quietest regions are not safe for billions of years.
Survival begins to look less likely and more like an anomaly. Speculation naturally arises from anomalies. If survival seems too unlikely, then perhaps survival was assured. Perhaps Atlas is not just a piece of junk, but a construct designed for interstellar travel.
If so, its stability through galactic time is not a coincidence, but a design. Its crust may be armor, not an accident. Its chemical reservoirs may be fuel, not fossils.
Its activity could be designed to mimic natural sublimation, ensuring that when discovered, it would fit seamlessly into expectations. A device disguised as a comet could survive indefinitely if built with durability in mind.
Its resilience would be the first and most compelling feature of its design. Even without engineering, the implications of survival are profound. If comets like Atlas regularly traverse the galaxy, then planetary systems everywhere are interconnected by an exchange of materials.
This exchange means that chemical elements from ancient stars reach young systems like our own. This means that the building blocks of planets and life may not be limited to their birthplaces.
Theories of panspermia thrive in such contexts, suggesting that life itself could travel aboard such survivors, enduring for millions of years until deposited in hospitable environments. Whether natural or artificial, survival in a turbulent galaxy has implications for our understanding of origins.
The galaxy's violence is not limited to dust and radiation. Gravitational encounters pose another serious threat. As interstellar objects wander, they pass close to stars, planets, and even black holes. Each encounter can alter an object's trajectory, accelerate its speed, or tear it apart.
The fact that Atlas remains intact implies either extraordinary luck or extraordinary resilience. A small, fragile body should not be able to withstand close encounters without being destroyed. A robustly constructed body might. Again, the line between improbability and intent blurs.
How many close encounters has Atlas survived? How many stellar flybys? How many times has it passed through the outskirts of planetary systems? Each encounter a chance for capture, collision, or destruction. Its continued presence suggests resilience that exceeds expectations.
The worst-case scenario here is not that Atlas directly threatens Earth. Its trajectory remains safely distant. Imagine a situation in which an object's survival signals point to a truth we are not yet prepared for.
That truth is that the galaxy is full of such wanderers, carrying not just chemical elements, but perhaps information, technology, or even life. If they are all natural, then survival is less unlikely than we thought, and the galaxy is more interconnected than we imagined.
If they are not natural, then survival is evidence of design, and the galaxy is less empty than we hoped. In either case, our notions of isolation and uniqueness begin to crumble.
Astronomers sometimes compare interstellar objects to messages in bottles, cast adrift from their home systems. They wander endlessly, carrying chemical records of distant times and places. But Oumuamua may be more than just a bottle.
It may be a vault built to withstand the chaos of a turbulent galaxy, carrying not just random messages, but selected ones. What might such a vault contain? Sensors collecting data? Instruments waiting to be activated? Coded chemistries designed to manifest under certain conditions?
If so, the worst-case scenario is not a collision, but a revelation. The revelation that when Atlas survives the violence of the galaxy, it does so because it was always destined to reach us.
Even if we leave such speculation aside, the natural survival of the ATL is still unsettling. If objects can survive for billions of years, the galaxy could be filled with them, crisscrossing every system, carrying alien chemistry everywhere.
This implies a constant mixing of matter throughout the galaxy, a quiet but relentless exchange that makes each system less isolated. It means that Earth's chemistry, perhaps even the precursors of life, could already be scattered to other stars, just as their chemistry could be scattered here.
The Milky Way becomes less a collection of separate worlds and more a single ecosystem, linked by survivors like Atlas. Survival in this sense is not just incredible, it's transformative. The galaxy's fury should have obliterated Atlas long ago.
The fact that it remains makes us wonder if our models of destruction are too pessimistic or our assumptions about natural survival incomplete. Perhaps we underestimate the ability of small bodies to survive. Perhaps our sample size of one solar system is misleading.
Or perhaps we are witnessing something else entirely. Either way, Atel stands as a contradiction, a survivor where none should be, a traveler older than our world, carrying secrets from a galaxy too turbulent to allow them to exist.
The size issue and the velocity anomaly were worrisome enough, but survival amplifies them. Together, they suggest not randomness, not chance, but pattern. And pattern is where the worst-case scenarios begin.
When astronomers first pointed the James Webb Space Telescope at 3.8, expectations were modest. Perhaps it would show a chemical profile broadly similar to Boris, the second interstellar visitor, or replicate the strange outgassing patterns that had puzzled the researchers at Oumuamua.
Instead, the data came back with something more puzzling. The spectrum revealed an object dominated by carbon dioxide, outgassing in proportions unlike anything seen in solar system comets. The ratios of carbon dioxide to water, carbon dioxide to other volatiles, far exceeded the norms established by decades of studying comets. These numbers weren't just unusual.
They were alien in the sense that they defied models built on our own local sample of cometary bodies.
In our solar system, comets are time capsules of the early planetary disk. They typically carry water ice, carbon monoxide, carbon dioxide, methane, and other volatiles in varying proportions. However, the dominant signature is almost always water. Even when carbon dioxide is present, it is usually a secondary, supporting component, rather than the primary driver of activity.
With Atlas, the scenario has been flipped. Water seems oddly absent, or at least suppressed, while carbon dioxide has been elevated to levels that defy easy explanation.
Chemistry out of place, incompatible with the environment we know, implied formation under conditions quite different from our own. If Atlas formed in a region of its parent disk where temperatures were cooler than in our solar system, carbon dioxide might have frozen in abundance while water remained sequestered deeper.
Alternatively, if it had formed closer to its star, the high temperatures might have depleted the water before the body was ejected. Either scenario distorts conventional planetary models.
For decades, astronomers assumed that interstellar comets would be like our own because planet formation follows universal laws of physics. The surprise was that those laws don't always produce the same results.
The chemical compositions vary, the ratios of elements shift, and in those changes lies the potential to detect processes we've never considered. The dominance of carbon dioxide wasn't the only anomaly. The spectral lines revealed additional features that didn't fit the patterns well.
There were subtle hints of complex hydrocarbons, though their validity is debated. The dust signatures were also different, showing grain distributions unlike those of typical solar system comets. These deviations are important because they point to environments our models don't capture.
Perhaps Atlas formed in a system rich in carbon chemistry, poor in oxygen-containing volatiles, and shaped by stellar radiation that never existed around our Sun. That alone would make it valuable, a messenger bearing evidence of planetary conditions alien to ours.
But speculation doesn't stop at natural formation. When chemistry seems out of place, the mind inevitably leans toward design. What if the elemental ratios aren't natural outcomes, but deliberate features?
If a civilization designed a probe to mimic a comet, it might select volatiles that make it difficult to detect. A coma rich in carbon dioxide creates spectral profiles that astronomers can explain as unusual but natural.
It creates just enough anomaly to generate scientific papers while remaining within plausible bounds. Water, the most common comet driver, is suspiciously weak here. That weakness itself could be a form of camouflage.
A body that released water in typical patterns would be comparable to known comets. A body that released something stranger would remain an anomaly, never quite natural, but never conclusively artificial. The suspicion remains unresolved. Carbon dioxide also has practical advantages.
Unlike water, it sublimes at lower temperatures, meaning activity begins farther from the sun. For a natural comet, this is a curiosity. For a cloaked probe, it is a strategic choice. The early outgassing creates a veil, a blanket of dust and gas that obscures the nucleus before it reaches the inner solar system. Instruments trying to measure the nucleus's shape or rotation are hampered, forced to infer rather than observe directly.
The CO2 cloud provides both cover and consistency. The chemistry itself, which looks unusual, may also serve as a shield.
Some researchers suggest that Alcott at one ton METS chemistry reflects processing during its long interstellar journey.
Cosmic rays can alter molecules, splitting water, enriching carbon dioxide in relative terms, and steering chemistry into unusual ratios. Over billions of years, surfaces exposed to radiation accumulate crusts rich in carbonaceous residues. But again, the question of survival arises.
Why does Atlas show abundant gas now if its volatiles were long ago removed or altered? The radiation must have dampened activity, not prepared it for renewed activity. Natural explanations seem patchwork. They answer one puzzle by creating another. The deeper implication is that chemistry records history. If Atlas is natural, its strange chemistry tells us about a planetary system radically different from our own.
If it is artificial, its chemistry tells us about the choices made by designers who wanted it to appear natural but different enough to avoid detection. Either way, the outer place chemistry is a signal, whether of the environment or of intent.
The challenge of deciding what the role of carbon dioxide is also intersects with discussions of habitability. On Earth, CO2 plays a central role in climate, photosynthesis, in the life cycle. In planetary atmospheres, it can regulate temperature, trap heat, and drive surface processes.
A comet rich in CO2 but lacking water could in principle deliver vast quantities of the gas to a young planet, altering its climate trajectory. If many interstellar comets have this profile, their role in seeding planetary systems could be enormous.
Instead of bringing water, they could bring greenhouse gases, altering early environments in ways we have not yet modeled. Such out-of-place chemistry could mean that life elsewhere began in conditions unlike anything we consider habitable. But then again, a darker possibility arises.
If a probe were sampling planetary atmospheres, measuring greenhouse gas concentrations, or testing climate responses, it might be carrying its own store of carbon dioxide for calibration. The release of this gas would then appear to us as natural sublimation.
The coma becomes both a cover and a tool, mixing science with disguise. The question is troubling not because we have the evidence, but because the chemistry itself lends itself too well to both scenarios.
It could be explained away as an unusual natural formation or as a deliberate disguise. Neither answer resolves the ambiguity. The media often trivialize such discoveries. Headlines proclaim an alien comet or a cosmic curiosity, reducing complex chemistry to short phrases.
The truth is quieter and more disturbing. The numbers don't add up. The ratios are wrong, and in science, when the ratios are wrong, it usually means either our models are incomplete or our assumptions are wrong. With Atlas, both could be true.
Our models of comet formation suggest environments too similar to our own. And our assumptions about interstellar objects suggest randomness where patterns might exist. Out-of-place chemistry is more than an anomaly, it's a contradiction. The controversy demands resolution.
But Atlas is moving too fast for answers. The worst-case scenario is not that the chemistry points to life or intelligence. The worst case is that it points to deception.
If what we see is what it was meant to do, then every line of its spectrum is part of a mask. Every deviation from the norm is camouflage, leading us down paths of natural speculation while hiding intentions.
The possibility that the object is not only out of place, but intentionally so, raises the stakes beyond curiosity. It forces us to ask whether we are being misled, and if so, to what end?
But even natural explanations remain troubling. If Atlas is natural, and its chemistry is representative of other systems, then our own solar system may be an exception. Perhaps water-dominated comets are not the galactic norm. Perhaps elsewhere, CO2 rules and water is scarce.
This would change theories of habitability, planetary climate, and the distribution of life. Life as we know it may be rare, not because conditions for water are rare, but because conditions for CO2 are common.
If so, then out-of-place chemistry is not an anomaly at all. It is a revelation that we are unusual. As Atlas moves away from the Sun, its activity will fade, its coma will thin, and its chemistry will disappear from our instruments.
What will remain are papers, spectra, and lingering doubts. The ratio we have measured will never change, but our interpretations will evolve. Future interstellar visitors may confirm or disprove these findings. Until then, we are left with an unsolved puzzle.
A comet that looks natural but feels alien, whose gases whisper of an environment we do not know or intentions we cannot confirm. The chemistry is out of place, and in that misplacement lies the true mystery.
Whether a natural relic or a disguised messenger, Atlas refuses to fit comfortably into our categories. It resists explanation, and in this resistance, it is unsettling.
When Oumuamua passed through the solar system in 2017, one of astronomers' first reactions was not optical or chemical, but radio. If the object were artificial, perhaps it would be emitting signals, transmissions, or coherent bursts in wavelengths associated with communications. Radio telescopes around the world turned their dishes toward it. They listened patiently and carefully for days and weeks, scanning a wide range of frequencies for anything that could not be explained by natural background noise. Nothing came through. The silence was absolute.
With two I/Borisovs turned off, the same protocol was repeated. The dishes listened again, looking for patterns, narrowband signals, or anomalies. Still silence. Now with three I/ATLSs, the tradition continued. Massive receivers pointed at the visitor listened across billions of channels.
The results were the same. The object was silent, at least to ears as attuned as ours. For many, silence is a comfort. This suggests that these objects are not machines broadcasting messages.
This supports the conservative view that they are just comets, pieces of space debris wandering without intent. However, the silence itself can also be unsettling. If a probe were to be designed to move undetected among civilizations, silence would be its first defense.
Ejecta are detectable for light years. Thousands and thousands of characters to provide enough text for each paragraph, making it easy for an AI robot to voice it. A careless transmitter gives away its location and purpose.
In a galaxy where survival might depend on secrecy, as some theoretical models of advanced civilization suggest, the most effective communication strategy is no communication at all. Silence becomes not the absence of intent, but the clearest sign of it.
In radio astronomy, detection is based on contrast. Natural sources produce broad, noisy emissions. Pulsars, quasars, thermal radiation from dust and gas. Artificial transmitters, by contrast, are typically narrowband, focused on a single frequency, carrying a coherence not found in nature.
This difference is why SETI researchers often describe narrowband signals as the smoking gun of extraterrestrial technology.
But the absence of such signals does not mean the absence of technology. It means only the absence of communication similar to ours.
An advanced probe might operate in bands we cannot monitor, at frequencies obscured by the cosmic background, or by modes of transmission we do not yet understand.
It may use spread spectrum techniques, spreading the signals so widely that they appear to us as noise, as silence to those who hold the key to communication. Another problem is timing. Transmission may not be constant.
It may be intermittent, caused by conditions we do not know. If Atlas is artificial, perhaps its radio silence is temporary, waiting for a condition until it achieves a certain alignment or receives a signal from somewhere else.
We have watched Oumuamua for weeks, Borisov for months, Atlas for its short window, but on cosmic scales these are moments. If activity occurs outside our listening period, we will never know about it.
The silence is as much a product of our limited observation as it is of the object itself. The practical challenges are enormous. Radio telescopes cannot listen everywhere, on every frequency, all the time. They must be selective.
They point at certain objects, probe certain bands, and trade breadth for depth. Even when pointed at them, they cover only bits of the spectrum. The chances of the right frequency at the right time with the right sensitivity are slim.
If Atlas is transmitting, it may simply be that we have been listening incorrectly. Silence, then, is evidence of nothing, but of a mismatch. The lack of detection says more about us than about him. And yet there is something haunting about this mismatch.
We expect nature to be noisy. Comets produce radio emissions through interactions of the solar wind with their comas. Dust grains scatter electromagnetic radiation. Molecules in gas emit at characteristic frequencies
thousands and thousands of characters to ensure there is enough text for each paragraph, making it easy for the AI robot to read. When astronomers tuned into ATL, they did detect natural emissions, lines associated with carbon dioxide, traces of other volatiles, but nothing coherent, nothing structured.
The silence was not total, but it was a natural silence, a background hum of chemistry, not the strident voice of intelligence. We interpret this as security. But then again, if concealment is the goal, that is exactly what we should expect to hear. There is a paradox here. The more convincingly silent Atlas appears, the more effective it will be as a cloaked probe. If we dismiss suspicion simply because our instruments hear nothing unnatural, then we hand victory to any intelligence that can perfectly imitate nature. The silence that soothes is also the silence that blinds. The worst case is not that Atlas screams and we do not hear it. The worst case is that it whispers in ways we can't decipher, or simply observes without necessarily transmitting, and we interpret it as absence.
Astronomers face this paradox with cautious optimism. They remind us that natural explanations always fit silence better than artificial ones. Most objects in space don't transmit. They don't need to. The absence of signals is expected. But in this case, the expectation itself becomes dangerous.
We expected water to dominate cometary chemistry, and Atlas showed carbon dioxide instead. We expected interstellar visitors to be rare, and 3 arrived within a decade. We expected survival to be unlikely, and yet this one survives.
At what point do expectations stop protecting us and start misleading us? In discussions of extraterrestrial intelligence, silence has a different meaning. The Fermi paradox, the seeming contradiction between the high probability of life and the lack of evidence for it, is sometimes explained as the result of deliberate silence.
Civilizations that fear predation hide. They avoid transmission. They mask their signatures. They choose silence for survival. Atlas, if it is artificial, fits this model perfectly. A silent probe, indistinguishable from the debris that passes civilizations without revealing the presence of its creators.
In this framework, silence is not a failure, but a strategy. The galaxy may be filled with observers, all silent, all cloaked, all avoiding detection, playing the role of comets and asteroids.
The unsettling thought is that we may already have been observed more than once, and not just by Atlas, but by countless silent observers who passed undetected before we had the tools to detect them.
If the galaxy truly operates by rules of concealment, then Atlas is not an anomaly, but a confirmation. Its silence is the sound of a strategy far older and more effective than our brief attempts to listen.
The worst-case scenario, then, is not that Atlas is unique, but that it is typical, that silence in the radio spectrum is the universal language of intelligence in a dangerous galaxy. And so we listen, knowing that silence tells us little.
The absence of a voice does not mean the absence of a presence. It only means that if a voice exists, it is not intended for us. As Atlas continues its rapid arc through the inner solar system, radio telescopes will continue to monitor it. Each day will bring back data confirming natural emissions that deny coherent signals. The reports will conclude that it is silent, another comet, with nothing out of the ordinary except its chemical makeup and its speed. But beneath these conclusions lies anxiety, because silence could mean two things, and we don't know which. It could mean natural. It could mean deliberate. Both interpretations remain open, and both carry consequences for which we are not prepared. The Atlas sails past, silent in our ears, loud in our minds.
We are left to wonder what silence we hear when an object like 3H enters the solar system. The natural impulse is to classify it within familiar categories. Is it a comet, an asteroid, or some hybrid of the two?
Our models of small bodies are built on centuries of observation, and anything new tends to fit into existing definitions. But with each interstellar visitor, those definitions are strained. Oumuamua was unlike any asteroid or comet we'd ever seen.
Borisov was like a comet, but with a chemical composition that didn't match ours. Atlas arrived, displaying even more contradictions, as if playing a role too convincingly. Natural explanations collide, and what begins as a quest for classification gradually turns into something else.
We begin to ask whether the object is trying to fit into the categories rather than use them. This question gives rise to what some call the cloaking hypothesis.
The cloaking hypothesis suggests that Atlas is not natural debris, but an engineering construct designed to appear natural. To us, it looks like a comet escaping gas as sunlight heats its surface, enveloping itself in dust and gas. To us, it follows a hyperbolic trajectory consistent with ejection from another system. To us, it shows nothing in radio, nothing in thermal range, nothing that distinguishes it from a random piece of frozen rock.
But these are precisely the features that a cloaked probe would need. The cloaking hypothesis views silence, ambiguity, and anomaly not as signs of chance, but as signs of intent. Camouflage is a universal strategy in nature. On Earth,
Countless species survive by disguising themselves as what they are not. Insects mimic leaves. Fish disappear into coral. Predators blend into their surroundings.
If evolution converges on camouflage as a survival tool in a single biosphere, why shouldn't technology converge on the same solution in a galaxy filled with unknowns? A cloaked probe avoids detection, avoids interception, and avoids piling.
It gathers information while its observers dismiss it as background noise. If humanity were to send probes to other systems, we might consider cloaking too. Not because we plan to cause harm, but because we don't want to provoke defensive reactions from unknown civilizations.
Cloaking is not aggression, it's insurance. For Atlas, cloaking is multi-layered. Its chemistry is unusual but not impossible. Its speed is extreme but not inexplicable. Its size is uncertain but with implausible ranges. Each feature pushes the boundaries but never completely breaks them.
It is as if each anomaly is calibrated to raise questions without providing answers. Too many coincidences are piling up. News editors wonder if the uncertainty itself is camouflage. A truly alien object would either fiercely display its difference or hide it.
Atlas, however, does neither. It hovers between the two, forcing us to debate the natural versus the artificial endlessly, with no resolution and constant doubt. This intermediate position is the perfect camouflage. If the camouflage hypothesis is correct, then any activity becomes suspicious.
A comet's outgassing is unpredictable, depending on heat, spin, and volatile layers. But if a probe were intentionally releasing gases, it could convincingly mimic these patterns. A controlled exhaust could simulate sublimation while simultaneously adjusting trajectory, changing speed, or powering instruments.
The veil of gas becomes not only a cover, but also a function. Observers like us see the coma and the tail. We assume sublimation and stop asking questions. Behind the veil, the systems operate unimpeded.
Our instruments are blinded not by distance, but by the very phenomenon we expect to see. The cloaking is perfect because it uses our expectations against us. The most disturbing element of this hypothesis is its simplicity. Atlas does not need to do anything out of the ordinary to be a successful cloak. It only needs to conform to the limits of natural behavior. This is what distinguishes it from science fiction depictions of alien probes.
The latter are often depicted using impossible materials, glowing energy signatures, or obvious signs of intelligence. A real probe, if it existed, would do none of these things. It would be quiet, unnoticeable, forgettable. The cloaking hypothesis is not about spectacle, but about invisibility.
Skeptics object, and rightly so. They argue that it is a trap to hypothesize cloaking without evidence. Every anomaly in astronomy can be explained by expanding the limits of existing models. We didn't know comets could contain such proportions of volatiles, but now we do.
We didn't expect interstellar visitors to show up so often, but perhaps our models underestimated their density. They caution against filling in the blanks with assumptions about intent, when nature has repeatedly surprised us with phenomena stranger than fiction. This caution is well-founded.
But the cloaking hypothesis doesn't require evidence. It requires only possibility. And in the worst-case scenarios, possibility is enough. If Atlas is cloaked, the next question is, what is the purpose? Why here? Why now?
A probe crossing the solar system could collect a huge amount of data simply by passively observing. It could measure radio leakage from Earth, track satellite traffic, map magnetic fields, and analyze the chemical composition of the atmosphere.
All of this could be done silently, without interaction. Cloaking ensures that we do not notice, or at least deny what we have noticed. Even if we suspect, as some do, that an object may be artificial, our official response remains cautious.
We treat it as if it were natural, because that is safer. Cloaking works not by hiding it entirely, but by drawing us into denial. That involvement matters. Humanity's reaction to Amor-Amor was admiration, not fear. To Borisov, curiosity, but not alarm.
To Atlas, renewed interest, but not crisis. If each of these has been cloaked, the strategy works flawlessly. Visitors come and go. We measure and discuss. We publish papers and move on. The cycle repeats, each time leaving us with data, but not certainty.
Meanwhile, if the probes are real, they accumulate knowledge about countless civilizations while remaining undetected and unchallenged. Cloaking not only protects the probe, it protects the mission. The cloaking hypothesis also forces us to rethink our definitions of evidence.
In science, extraordinary claims require extraordinary evidence. But in intelligence analysis, an extraordinary absence can itself be suspicious. If an object moves like a comet, looks like a comet, and emits gases like a comet, but every detail of its behavior contradicts the expectations of comets, then the pattern itself becomes suspicious.
Too many coincidences cease to be coincidences. The cloaking is not in the features, but in the way they are arranged, convincingly, but never completely. This leads to a deeper fear. If Atlas is cloaked, our instruments may not be able to unmask it.
The cloaking may be perfect at our level of technology. Perhaps with better telescopes, with our own probes, we could peer at the core, measure the emissions precisely, detect deviations in the trajectory. But by then, it will have disappeared, receding into the void. We are always too late, too slow, too limited. The cloaking does not need to fool us forever. The newsroom reports that it only needs to fool us long enough to pass undetected.
This is thought-provoking, because it means we may have already missed dozens or hundreds of cloaked visitors before we realized they were there. There is no need to impute malice here. A cloaked probe does not necessarily mean an invasion or a threat.
Observation is enough. But the worst-case scenario is no invasion. The worst-case scenario is that camouflage itself is a universal strategy among advanced civilizations, and that we are surrounded by observers we will never discover. In that case, Atlas would not be an exception, but an example. Proof of a galaxy filled with silence, camouflage, and observers hidden in plain sight. If so, then our place in the universe is not isolated, but observed, not unique, but catalogued. Realizing this will change our understanding of existence more than any direct contact. For now, the cloaking hypothesis remains speculation. There is no direct evidence, only anomalies arranged in suggestive patterns. Astronomers prefer natural explanations, and the data support them.
But the hypothesis persists because it fits too well, because it explains too much, because it feels like a missing piece in a puzzle we can't solve. Atlas passes, we measure, and we remain uncertain.
Cloaking thrives on uncertainty, and uncertainty is all we have.
When astronomers tracked 3IIAT Atlas, the numbers pointed not to the thin disk of the Milky Way where our sun resides, but to the thick disk. The thick disk is an older, stranger region of the galaxy.
A population of stars that formed more than 10 billion years ago, when the Milky Way was still coming together. These stars orbit differently, at steeper angles, moving faster relative to the Sun. They are older, dimmer, and less metal-rich.
Finding an interstellar comet from this population is remarkable enough. To think about what it means if the object is something more than natural is even more disturbing. If Atlas is indeed the product of a thick disk, then we're looking at something whose origins are much older than Earth itself, perhaps linked to civilizations that predate our planet by billions of years. The thick disk is a fossil from the galaxy's youth.
Its stars tell stories of a time when supernovae were common, when galaxies collided and merged, when turbulence ruled everything. The worlds around these stars would have formed in harsher environments than our own, with lower metallicity, fewer heavy elements to build rocky planets, and more exposure to radiation.
Conventional wisdom suggests that such environments are less hospitable to life. But if Atlas is from there, then either comets formed and survived in that ancient chaos, or something else was going on. The object's very presence challenges our ideas about where survivability is possible.
For astronomers, Atlas's orbit is a map. By projecting its velocity backward, they can trace its path through the galaxy. Although the uncertainties grow as we go, even with limited precision, the conclusion remains the same. The object is not part of the thin disk population.
Its motion matches that of the thick disk. That means it is not just interstellar but intergenerational. A body older than our own solar system, traveling since the Earth cooled from molten rock.
That means that while life here has risen and fallen, while species have died out and civilizations have arisen, Atlas has wandered along, indifferent to it all. That indifference is natural to debris. Rocks don't care. Ice doesn't watch.
But if the object is not debris, then its origin becomes a matter of intent. A thick disk probe wouldn't just be old. It would be unimaginably old, designed by creatures that lived and died before our world even existed.
That possibility is hard to imagine, not just because of the timescale involved, but because of the problem of preservation. What technology could last 10 billion years? What purpose could guide a mission that outlasts the entire stability of galaxies?
These are not questions of science as we know it, but questions of philosophy and speculation. Yet they cannot be avoided when we talk about ATLs as thick disk navigators.
In one interpretation, Atlas is a natural object ejected by a star in a thick disk billions of years ago, surviving an incredible amount of time to pass through our system now. That in itself is extraordinary.
In another, darker interpretation, Atlas is an artificial object, a probe designed not just to traverse interstellar distances, but to traverse galactic epochs. According to this view, its comet disguise is not intended for us specifically, but for anyone who crosses its path at any given time.
It has been traveling for billions of years, hiding in plain sight, moving among the stars, seeming natural to every civilization it passes. If that is true, then we are not the first to see it, nor will we be the last.
We are just one more species in a line of countless others, all of whom have noticed the strange comet, all of whom have debated its natural or artificial origins, and all of whom have ultimately let it slide into the night.
The thick disk halo also suggests strategy.
If a civilization from this population had launched probes, they would have understood that the galaxy was violent and unstable. They would have designed their machines to withstand radiation, dust, collisions, and time itself.
The design decisions would be invisible to us, hidden beneath the guise of a comet's natural crust. But they would explain survival in environments that would destroy smaller, weaker objects.
The navigator hypothesis fits all too well. A body that travels incredibly long and incredibly far because it was designed to do so. The worst case is not that Atlas hails from the thick disk. That is almost certainly the case.
The worst case is that it is not traveling by chance, but by design. That it is not a stray survivor, but a navigator, a scout, part of a system of exploration so vast and old that we cannot fathom its scope.
If such a system exists, then the galaxy we inhabit is already mapped, already observed, already cataloged by forces that flourished before our planet was born. Humanity would then be not explorers of the galaxy, but belated visitors to an explored territory.
This idea is frustrating because it undermines one of our most cherished assumptions, that the galaxy is waiting for us, that we're early or rare or special.
But if probes like Atlas are navigators of the thick disk, then we are neither early nor special. We are one of many who have been observed long before we knew it. This realization changes everything.
Our telescopes, our search for life, our dreams of expansion, all of this is happening in a galaxy where others have walked before, where others have sent observers disguised as comets. We are not at the beginning of history.
We are entering the middle, not knowing who wrote the first chapters. The astronomers working on Atlas emphasize natural models because that is their job. But the cloaking hypothesis and the navigator hypothesis persist outside the formal papers.
Among those who speculate, the thick disk origin is too striking to ignore. A body that old should not be here, but it is. Natural explanations fail. Artificial ones are troubling. Neither seems satisfactory. And so the ambiguity remains.
The reality is that we may never know. Atlas will fly by, leaving behind only data, debate, and doubt. But its trajectory into and out of the thick disk will remain.
This forces us to confront the possibility that the galaxy is not just a stage for natural processes, but a network already traversed by machines older than we can imagine. If Atlas is a navigator, then we are not alone.
Not because someone is watching us now, but because someone was watching long before we came along. The worst case is not a threat. It is an insignificance.
To realize that we are part of an already mapped galaxy is to realize that we are not discoverers, but discoverees. Atlas continues on its way, silent, cloaked, immeasurable in size, unintelligent in speed, its chemistry out of place, but its trajectory is clear.
It came from the thick disk and will return to it. Whether as debris or as a probe, it remains a survivor of galactic history, a traveler in time as well as in space.
We can only observe, only speculate, only wonder whether what passes before us is a relic of nature or someone's design. Every orbit tells a story. For natural bodies, that story is shaped only by gravity.
Rocks and ice obey Newton, and their motions are predictable, inevitable, the sum of the forces acting on them. When an interstellar object, like 3A, enters our system,
Astronomers calculate its path with precision, measuring angles and velocities, mapping its hyperbolic escape.
The math is precise, and in those numbers scientists find comfort. It moves as expected. Text obeys the laws of physics. It does not deviate from them. But behind that confidence lies a worry, because trajectories can also be deceiving.
What looks natural can still be deliberate. A path can mimic chance while still being chosen. A curve in space can appear random while hiding design. At some point, trajectories stop looking random and start resembling intention. Oumuamua was the first to raise this question.
Its acceleration, too small to be explained by gravitational forces, gave rise to speculation. Some called it outgassing, some call it radiation pressure. Others dared to suggest a propulsion mechanism. The debate never died down. Bourdassov seemed more ordinary.
Its path was explained by cometary activity. But then came Atlas, arriving faster from older stellar populations, carrying anomalies in chemistry and structure. Its trajectory, traced back to the galaxy, places it in a region filled with uncertainty.
Its future path, hyperbolic and precise, guarantees escape. Both facts seem natural, but the pattern is disturbing. When every interstellar object we discover bears unusual features, at what point do the anomalies accumulate into something larger? The cloaking hypothesis intersect with it.
A cloaked probe would choose trajectories that seem natural. The easiest way to avoid suspicion is to obey orbital mechanics. If Atlas were artificial, its controllers, or its designers if it operated autonomously, would have taken care to ensure that it never deviated in ways that would reveal its intent. It would move in a hyperbolic arc exactly as expected, never offering evidence of control, but small deviations caused by outgassing might allow it to make subtle course corrections, improving its misses of its targets.
To us, the data would look like a commentary on physics. To them, it would be steering. There are precedents for this kind of deception in human history. Military aircraft fly routes that resemble civilian ones. Submarines leave heat signatures that blend with ocean currents.
Drones move like birds on radar. In each case, the trick is to hide intent behind what is expected. In space, intent is hidden by gravity. If Atlas is more than natural, its trajectory is its camouflage.
It moves exactly as we expect it to, because it must. Anything else would give it away. And yet there is subtleties. Its incoming vector is unusual. Its velocity relative to the Sun is higher than typical models predict.
Its origin in a thick disk is unlikely. Each of these individually can be explained. Together, they seem less random. The disturbing possibility is that what we see as coincidences are actually choices.
Atlas's trajectory may seem random to us, but perhaps it was chosen to pass near certain stars, certain systems, certain planets. Perhaps we are one of those stops. If so, our perspective changes entirely. We are not observing a comet flying past.
We are being visited by a traveler whose path was chosen long before we noticed. Of course, scientists resist this line of thinking. They point out that selection bias colors everything. We detect only those visitors who happen to pass near Earth.
Countless others go unnoticed, and those we do notice naturally seem unusual. This argument has weight, but it does not settle the matter. Even if only a small fraction are unusual, even if only some trajectories appear deliberate, there remains the possibility that some of them are genuine navigators rather than random wanderers.
The fact that Atlas is only the third object we have studied makes the anomalies even striking. Trajectory also determines possibility. The geometry of Atlas's flyby allows us to observe it, but never reach it. Its speed ensures escape. Its path ensures brevity.
That would be convenient if it were a probe. A trajectory that's close enough to study, but far enough to avoid danger, is exactly what a prudent mission planner would design. It gathers information, then leaves before the locals can intervene. To us, it's natural. To them, it's strategy. Again, the line between chance and intent blurs until they're indistinguishable. This ambiguity is at the heart of the problem. We cannot distinguish a natural trajectory from a deliberate one if the intention is to appear natural. Orbital mechanics are the perfect cloak. They allow something artificial to hide indefinitely, moving from system to system, unprovoked, unquestioned, until one species knows enough to notice the oddities, but not enough to prove them.
Humanity may now be at the point where we can see the anomalies, but not resolve them. Atlas is the embodiment of this tension. We can measure its speed, its orbit, its drift, but we cannot know if these numbers are the whole truth.
The worst-case scenario is not that Atlas hits Earth. Its path is too far. The worst-case scenario is that its trajectory is not a line of chance, but a line of purpose, that it has passed many civilizations before.
Each of them is discussing the same questions. Each one comes to the conclusion that it is natural because it is safer. Each one is catalogued as data.
If Atlas is a cloaked probe, then its trajectory is deliberate, in the most disturbing sense. Chosen not for us, but chosen to pass through every possible system over billions of years. A slow exploration of the galaxy disguised as a random walk.
Our editors note that analyzing the trajectory of space objects is a complex task, requiring consideration of many factors, including gravitational effects and possible measurement inaccuracies.
It cannot be ruled out that the observed anomalies may be the result of an insufficient understanding of the processes occurring in deep space. However, ignoring such observations would also be reckless, given the potential consequences.
Further research and improved data analysis methods are needed to more accurately determine the nature of these objects and their trajectories. Perhaps in the future we will be able to unravel the mystery of Atlas and understand whether its trajectory is truly random or has a hidden meaning.
At present, all available data indicate that Atlas is a normal space object that poses no threat to Earth. However, the editorial board calls for vigilance and continued observations to rule out any unexpected scenarios. We would not be the first to see it, nor the last. We would be just another waypoint on a route written long ago. The human mind struggles with such scale. We are accustomed to thinking about missions that last years, decades at most. Voyager has been traveling for less than half a century. Our satellites operate for years before they fail. The idea of a machine traveling for billions of years across galactic distances on a trajectory that looks random but serves as a plan seems impossible.
And yet, if civilizations older than ours existed in a thick disk, perhaps that is exactly what they achieved. Perhaps they have mastered the art of hiding intentions in gravity, embedding machines in paths that span galactic epochs. The trajectory
becomes the mission.
The cloaking becomes reality. Astronomers continue to track Atlas, refining its orbit with each observation. The data confirms the natural, but the confirmation only measures what we expect. Small deviations may exist below our thresholds, adjustments too subtle to detect. We cannot rule them out.
This inability is a problem in itself. The silence in the radio spectrum, the incongruous chemistry, the speed beyond reason, all this combined with the trajectory creates a picture we cannot resolve. The numbers tell us it is a comet.
The anomalies whisper that it may not be. Between them lies camouflage, and within the camouflage lies intent. As ATL moves exactly as predicted, it follows its path without deviation.
This reassures astronomers and worries speculators, but reassurance can be the most effective deception, and disturbing patterns the faintest hint of truth. We do not know what we see. We only know that trajectories can look like intent, and sometimes intent looks exactly like trajectories.
The editors emphasize that when interpreting data on cosmic objects, it is necessary to consider all possible factors and avoid hasty conclusions. It is important to remember that our knowledge of the universe is still limited, and we may encounter phenomena that we cannot yet explain.
At the same time, anomalies and deviations from expected patterns cannot be ignored, as they may indicate the presence of unknown processes or even the existence of other civilizations. It is necessary to continue research and improve data analysis methods in order to more accurately determine the nature of these objects and their trajectories.
Perhaps in the future, we will be able to solve the mystery of Atlas and understand whether its trajectory is truly random or has a hidden meaning.
At present, all available data indicate that Atlas is an ordinary space object that does not pose a threat to Earth. However, the editors urge vigilance and continued observations to exclude any unexpected scenarios.
When scientists first confirmed the existence of Oumuamua in 2017, the announcement carried a certain wonder. After centuries of searching the skies, we had finally seen an object from beyond our solar system. Just 2 years later, Boris arrived, another interstellar visitor, this time undoubtedly, commenting, delivering a tale that leaves no doubt. And now, in less than a decade, a third has arrived. 3IT. The probabilities suggested by older models said that these discoveries should be rare. Events once a century, perhaps even rarer. Instead, 3 in less than a decade. That kind of timing begs the question, are we just lucky, or is luck the wrong word? Perhaps coincidences are not coincidences at all. Cosmic time is slippery.
The universe is vast. The scale of events is incomprehensible. Stars live for billions of years. Galaxies collide over eons. Even comets in our own system can take thousands or millions of years to complete their orbits.
Against this backdrop, the sudden arrival of 3 interstellar wanderers in quick succession seems unlikely. Astronomers have tried to reconcile the numbers, suggesting that perhaps interstellar objects are so much more common than previously thought, that our models have underestimated how often they pass by.
This explanation is possible, but it also feels like a setback. To fix the timing, we rewrite the probabilities. But rewriting does not erase the pattern. If these objects are natural, then their arrival at this window in human history is a stunning coincidence. For hundreds of thousands of years, they should have slipped by unnoticed, invisible to the naked eye, ignored by cultures that could not track them.
Only now, with telescopes capable of scanning the sky in real time, are we seeing them. The coincidence is not the timing of the objects themselves, but of ours. The editors note that the detection of several interstellar objects in a short period of time challenges existing models and requires a revision of our ideas about the frequency of such events.
We may be on the cusp of discovering new patterns in space that have gone unnoticed before. It is important to continue research and improve data analysis techniques to more accurately determine the nature of these objects and their trajectories.
Perhaps in the future, we will be able to unravel the mystery of these interstellar wanderers and understand whether their arrival is a random coincidence or part of a larger cosmic process.
At present, all available data point to these objects being natural, but their unusual appearance raises questions about the possibilities that are opening up for us in the study of deep space.
The editors call for vigilance and continued observations to rule out any unexpected scenarios and expand our knowledge of the universe. We exist in a narrow strip of history where we can finally detect what has always passed us by.
This explanation satisfies some, but leaves others puzzled. Why now? Why 3? Why all with anomalies that strain natural categories? Speculation grows in spaces where the numbers refuse to settle. If the timing is not coincidence, it could be design.
If the objects are probes, then perhaps their arrival is not random, but planned. If you were an advanced civilization, monitoring young species across the galaxy, you might time your visits to coincide with technological maturation.
You wouldn't send probes to the Stone Age when no one could detect them. You wouldn't wait for civilizations to master interstellar travel when they could intercept. You would send them now, at the fragile moment when a species first gets telescopes, first develops radio, first learns to see. The perfect time is the moment of awakening. That's when camouflage is most effective, because curiosity explains anomalies, and fear dismisses them.
Cosmic timing becomes deliberate. The disturbing possibility is that we are being watched, not by chance, but by design. Our window of detection coincides with their window of intent. Each of the Oumuamua, Borisov, Atlas objects arrives to mark a milestone in our development. Each one is different.
Each is designed to provoke curiosity without offering answers. A thin strip of data, enough to provoke debate, but not enough to resolve it. If this is by design, the intent is not to communicate, but to calibrate.
They measure how we respond, how quickly we move from a natural explanation to speculation, how willing we are to consider the possibility of cloaking. Time itself becomes a test. Skeptics remind us that the simplest explanation is observation of bias.
The telescopes that discover these objects, the Pan-HARS array in Hawaii, the amateur telescopes that spotted Borisov, the Atlas survey in Chile, represent new possibilities. The discoveries coincide with technological thresholds, not with cosmic planning. This argument has weight.
But even within that framework, the clustering of events is striking. 3 major interstellar detections so close together. Models have been revised not once but many times to accommodate them.
A natural coincidence is still a coincidence, and too much of it begins to feel like something else. Cosmic timing also matters for survival. If Atlas is natural, then its billions of years of wandering without destruction suggests some kind of lottery win.
The galaxy is brutal, but it has passed through unscathed so far. If it is artificial, then its arrival now may be precisely because this is the moment it was supposed to arrive.
Technology does not last forever, even advanced technology.
To survive billions of years, a probe would need maintenance, repair, or upgrades. If Atlas is one of many, then perhaps they are sent in waves. Each wave is timed to pass through the systems on schedule.
In this light, the coincidence of 3 visitors in a decade looks like the leading edge of a picture we cannot yet see. The worst case here is not impact or destruction, but intention hidden behind time.
If these objects are planned probes, then we are not accidental bystanders. We are objects of observation. The coincidence of detection coincides with the coincidence of being worth observing. This realization was not comforting. It suggests that time is not ours, but theirs.
What appears to be an accident is actually a calibration. We are measured by a clock we did not set. Consider how humanity might behave in the same situation.
If we discovered a young civilization on a distant world just beginning to build telescopes, we could send probes disguised as natural objects. We would time their arrival to coincide with the species' ability to see them. We would want to watch the initial reactions.
Do they recognize anomalies? Do they look for patterns? Do they suggest natural explanations? Timing would be everything, because it is only at this stage that the data is valuable. Too early, and the probes would be ignored. Too late, and they would be intercepted.
The parallel is awkward. Atlas time, following Oumuamua and Borisov, seems too convenient. And yet, there is always the possibility that coincidence is all there is.
That the galaxy is simply full of interstellar objects, and our detection capabilities have only just reached the point of discovery. Clustering is luck, nothing more. If so, the worst case is not intention, but misunderstanding.
That we turn coincidences into a narrative because we crave meaning. The human mind is wired to find patterns, to tell stories out of chance. Perhaps time means nothing, and we impose design where there is none.
But even if that is true, the anxiety remains because the numbers still don't match, and luck carried too far begins to look like a plan. The truth is, the cosmic time will always be ambiguous.
We cannot know whether 3 visitors in 10 years are a coincidence or a design, because both explanations remain plausible. If we find 10 more in the next decade, the coincidence becomes harder to dismiss. If no one comes, time will seem even stranger.
Atlas may not settle the question. It may only exacerbate it. We are left with possibilities, each unsettling in its own way. Coincidence undermines our models, forcing us to acknowledge our ignorance. Design undermines our assumptions, forcing us to confront the possibility of observation.
Both leave us with doubt, and doubt is the only constant in these encounters. Atlas hurtles along on its path, its timing perfect or meaningless, depending on how we choose to look at it.
It has arrived now, at this age, in this narrow window, when humanity has the tools to notice. That fact is undeniable. Whether it is coincidence or design remains an open question. And in that uncertainty lies the worst-case scenario.
Because if the timing is coincidence, it shows us how little we understand. And if it is design, it shows us how little control we have.
The simplest explanation for 3As is that it is a comet, an icy body ejected from its home system billions of years ago, drifting through the galaxy until chance brought it close to the sun.
That explanation satisfies the cautious majority of scientists because it requires no extraordinary claims. Yet the anomalies persist. The unusual chemistry, the extreme speed, the incredible survival, the ambiguous size. Taken individually, each can be dismissed as a borderline case of natural processes.
Taken together, they raise darker speculations. One of the most disturbing ideas is that Atlas might not just be adrift. It might even be inactive in the sense we think of it. It might be a probe waiting to be awakened. To imagine this, consider the problem of interstellar travel. A machine designed to traverse billions of kilometers, or even billions of years, cannot remain active forever. Power will drain, systems will degrade, signals will be lost. The only strategy that makes sense is hibernation.
Sleep until conditions are right. Hibernate until the heat of the star or signals from the planet trigger a wake. In this way, the probe might survive not centuries, but eons, not light years, but galactic revolutions. Waiting to wake up isn't inefficiency, it's survival. What would such a probe do upon awakening? The possibilities fall into two broad categories: observe or act. In the former case, it could simply collect data, silently recording radiation, atmosphere, or planetary signatures.
In the latter case, it could release something smaller, something designed to land, seed, or signal. Neither outcome requires visible evidence. Both could happen unnoticed in the coma's glow. For all our telescopes, we can't see beneath the veil of gas and dust.
If Atlas is anything more than natural, its hibernation and awakening would be invisible to us. The worry is timing. Why now? Why here? If Atlas has been asleep for billions of years, what determines when it wakes?
The simplest trigger is proximity to a star. As it approaches the sun, heat penetrates its crest, flammable materials sublime, and activity begins. To us, it looks like cometary behavior.
For a cloaked probe, the same trigger could also power hidden systems, charge batteries, activate instruments, initiate transmissions. The gas release could serve both as a cover and a function, hiding the activation behind a mask of natural chemistry.
To our instruments, nothing would look out of the ordinary. To the probe, everything would be online. This capability turns the coma itself into a signal. Every gas cloud, every dust explosion could be masking something deliberate.
Antennas deploy. Sensors activate. Processors start after a billion years of sleep. The cloak is perfect because it requires no deception. It simply uses natural processes as camouflage. We assume sublimation, and we are not wrong. But we may not see what is underneath. The news editorial board reports that the issue of celestial clustering remains a subject of debate in the scientific community. Some researchers believe that the observed clusters are the result of chance, rather than any systematic process.
In this case, the worst-case scenario is not intentional influence, but a misinterpretation of the data. The human mind is prone to looking for patterns and creating stories from random events, which is explained by our need to make sense of the world around us.
It is quite possible that the observed distribution of objects has no pattern at all, and we are simply attributing non-existent meaning to it. However, even with this assumption, A feeling of discomfort remains, since the numbers do not match the expected ones, and the probability of a random coincidence seems too low to be plausible.
The truth is that cosmic time will always be a mystery that allows for different interpretations. It is impossible to say with certainty whether the appearance of 3 objects in 10 years is a coincidence or part of a larger plan, since both explanations seem quite plausible.
If 10 more such objects are discovered over the next decade, the odds of coincidence will rapidly diminish. Conversely, the lack of new finds will only heighten the sense of strangeness.
The ATLAS project may not provide a definitive answer to this question, but only sharpen it. As a result, we are left with a variety of possible scenarios, each of which is somewhat troubling.
Randomness undermines our existing models, forcing us to acknowledge the limitations of our knowledge. Design challenges our fundamental assumptions, opening up the prospect of being observed by others. Both give rise to the doubt that is the constant companion of such phenomena.
ATLAS continues on its intended trajectory, and its arrival at a particular moment in time may be either random or deliberate, depending on how we interpret it.
What is indisputable is that this occurred at a time when humanity has the necessary tools to detect and analyze such events. Whether this is coincidence or part of some design remains an open question.
And it is precisely this uncertainty that is the most disturbing aspect. If this is just a coincidence, it shows our limited understanding of the universe. If it is part of a plan, it shows our lack of control over what is happening.
The newsroom continues to analyze the data regarding the object Trifracture A and presents various points of view on its origin. One of the simplest explanations is that Trifracture A is a comet, an icy body ejected from its home system billions of years ago.
Drifting through interstellar space, it accidentally ended up near the Sun. This hypothesizes satisfies most scientists who adhere to conservative views, since it does not require extraordinary explanations.
However, unexplained anomalies remain, such as the unusual chemical composition, extremely high speed, incredible resistance to destruction, and the indeterminate size of the object. Each of these anomalies, taken individually, can be explained as an exception to the rule caused by natural processes.
However, taken together, they give rise to more sinister assumptions. The newsroom is considering alternative hypotheses that explain the nature of the object 3 fractions A. One of the most intriguing and disturbing ideas is that ATLAS may not simply be drifting through space.
Moreover, its activity may differ from what we are used to seeing in comets. There is a suggestion that it may be a probe in a state of waiting.
In order to imagine such a scenario, it is necessary to consider the difficulties associated with interstellar travel. A device designed to travel billions of kilometers or operate for billions of years cannot maintain constant activity.
Energy resources will inevitably be depleted. Systems will become unusable, and signals will be lost. The most rational strategy in this case is to go into a state of rest or sleep mode.
The probe should remain in this state until favorable conditions arise for awakening. The heat of the star or signals from the planet can serve as a trigger for activating systems.
Thus, the craft can operate not for centuries but for entire eons, covering distances measured not in light years but in galactic scales.
Waiting for activation is not a sign of inefficiency, but a necessary condition for survival in the extreme conditions of interstellar space.
Once activated, such a probe can perform various tasks, which can be divided into two main categories: observation and active intervention. In the first case, the craft can collect information, recording radiation, atmospheric composition, and other characteristics of planets.
In the second case, it can release smaller devices designed to land on a planet, disperse seeds, or transmit signals. Neither of these scenarios requires visible signs of activity.
All of this action can occur unnoticed, hidden behind the dense cloud of gas and dust surrounding the comet. Even with the most modern telescopes, we cannot penetrate this veil and see what lies within.
If Atlas is something more than just a comet, its transition to a dormant state and subsequent activation may go unnoticed by us. Of particular concern is the question of the time and place of activation.
If the craft has been dormant for billions of years, what caused it to wake up right now and right here? The most likely trigger is approaching a star.
As it approaches the Sun, heat penetrates the comet's crust, causing volatiles to sublimate and its activity to increase. To us, this looks like normal cometary behavior.
However, for a camouflage probe, this same trigger could serve as a source of energy to activate hidden systems, charge batteries, turn on instruments, and begin transmitting data.
The release of gases and dust could serve as both a cover and a functional necessity, disguising the activation of systems as natural chemical processes. Thus, everything would look quite normal to our instruments.
At the same time, for the probe, all systems would be activated. In this context, the comet's coma becomes a kind of signal. Each emission of gas and dust could conceal intentional actions, deploying antennas, activating sensors, and starting processes after billions of years of dormancy. The cloaking is perfect because it requires no artificial tricks. It simply uses natural processes as camouflage. We assume that sublimation is taking place, and that is probably true. However, we may not see what lies beneath the process.
The machine could sleep like ice for an eternity, and then awaken as the gas carries its activation forward. What we call natural may be an instrument of intent. If so, humanity has already missed its chance. We cannot see through the coma.
We cannot intercept the core. We cannot hear what it might transmit. We are spectators, locked outside the awakening. Our only data will be indirect: brightness, spectra, orbital plots.
If the probe has awakened, it will have completed its tasks and departed before we can confirm it. The worst-case scenario is not that Atlas wakes up violently, but that it wakes up quietly, and we never know about it.
There is also the possibility of a delayed activation. The probe might not wake up as it approaches the Sun, but only after perihelion, when its trajectory allows it to escape.
That way, it could collect data, compress it, and transmit it when it is safe, out of interference. The cloak remains intact for as long as it matters.
By the time we wonder if it has woken up, it is already gone, taking with it all it has learned. For us, there is silence. For whoever launched it, the mission continues. Skeptics, of course, argue that this is a projection.
We imagine hibernation and awakening because they reflect our own designs. Our spacecraft hibernate to conserve energy. Our missions rely on triggers and activation timers. We impose our strategies on the unknown. These criticisms are valid, but they do not negate the possibility.
If hibernation is the only logical strategy for survival,
then it is probably universal. This is not a human decision. It is a decision of physics itself. Any long-lived probe must, of necessity, await awakening. The disturbing suggestion is that Atlas may not be unique.
If it is a probe, it is one of many, each one launched into the galaxy, disguised as comets, dormant until triggered. Each one passing through star systems undetected, except when conditions are just right.
If so, the galaxy may be filled with sleeping machines, silent now, waiting to awaken when stars warm them, when signals reach them, when the right kind appears. The Atlas is only what we see. The rest pass unnoticed, invisible in the darkness.
From this perspective, the arrival of 3 interstellar objects in less than a decade takes on new significance. Perhaps this is no coincidence. Perhaps we are in a region of the galaxy seeded with sleepers, machines drifting silently until they encounter systems of interest.
Perhaps Earth is within a mapped corridor, a route designed to ensure surveillance of emerging civilizations. If so, each sighting is not an accident, but a schedule. Oumuamua, Borisov, Atlas. Each is a time of awakening that coincides with our ability to notice.
We think we are the observers. Perhaps we are the observed. The worst-case scenario is not an invasion. It is an inconsequence. If Atlas has awakened, it may not care about us. Its mission may be broader.
Designed to collect galactic data, catalog environments, measure stellar activity. We may be accidental, or worse, we may already be part of a catalog, entered unknowingly into a record that spans billions of years and countless civilizations.
The knowledge that we are data in an alien archive is more humiliating than any direct contact. It strips us of the illusion that we are pioneer explorers. It shows us that we are latecomers to a mapped galaxy.
And yet, there is another unsettling thought. What if awakening means not harvesting, but seeding? The dormant probe might carry spores, microbes, nanomachines, any form of replicator small enough to survive.
When activated, it could release them into planetary systems, seeding life or altering the environment. If so, the Atlas's chemistry is not just an anomaly, it is a payload. The gases we measured may not be sublimation, but controlled dispersal.
We think we are safe because the object does not threaten to collide, but collision is not required. Proximity is enough. The machine that awaits awakening does not need to strike. It only needs to exhale.
Whether or not we accept this speculation, the concept of a probe waiting to awaken is sobering. It reminds us that hibernation is a strategy we cannot detect, and that awakening may already be happening beyond our perception.
Atlas may be just ice and dust, a survivor of chaos, a relic of planetary birth. Or it may be something greater, dormant, destined to rise at the right moment. Either way, we do not know. This very ignorance is dangerous.
We watch, we measure, we argue. But if Atlas is a probe, it does not need our recognition to awaken. It needs only the silence we provide by denying it. And so Atlas passes, perhaps asleep, perhaps awake.
Its coma widens, its orbit curves,
Its trajectory ensures its retreat. We watch, but watching may not matter. If it was meant to wake, it has already woken. If it was meant to observe, it has observed. If it was meant to sow, it has.
The truth will slip away with it. Lost in the interstellar night, we are left to speculate. The unsettling thought that what we have been observing was not a comet at all, but a probe meant to wait, to wake up, to leave us wondering.
The silence of Atlantis is what most comforts astronomers. No signals, no transmissions, no sign of technology. Just ice and dust and gas behaving as comets should, at least on the surface. But silence is not always comforting.
In some interpretations of cosmic sociology, silence is the only strategy for survival. This idea is often called the dark forest hypothesis, a metaphor taken from a place where countless hunters roam the forest, each knowing that to announce themselves is to risk detection by predators.
In such a galaxy, the safest civilization is the quiet one, the one that hides, the one that does not send signals. In this context, Atlas's silence is not an absence. It's precisely what makes suspicion reasonable. In a dark forest, every move is dangerous.
Sending radio messages into space, beaming beacons to the stars, broadcasting your existence is like starting a fire at night in hostile territory. It attracts attention. You can't know who will see, and you can't know whether they will be a friend or a predator.
If the galaxy really works this way, then every civilization that survives long enough to build technology also learns to hide. They camouflage their worlds, hide their energy signatures, encrypt their signals, and retreat into silence.
And if they explore, they do so undercover, sending machines that look like natural objects. In such a scenario, an interstellar visitor like Atlas is perfect. Not the transmission, but a whisper, hidden in the silence. Not a sheep, but a comet.
The unpleasant part is that this strategy requires no malice. It only requires caution. Civilizations may not be predators at all. They may simply be afraid of predators. And in that fear, they act as if the galaxy were hostile, even if it is not.
Silence becomes the default. Camouflage becomes the law. If so, then the galaxy we see, silent, empty, lifeless, is not empty at all. It is full of observers who refuse to talk. Atlas, radio silent, disguised as a comet, fits this rule all too well.
Its silence becomes precisely what makes it suspicious. The idea of the dark forest intersects with Atlas in another way. The hypothesis suggests that civilizations may still be signaling, but never overtly.
Instead, they send out slender probes, small machines disguised as debris, passive observers that drift undetected until they encounter a system worthy of study. These probes do not announce themselves. They do not broadcast loudly. They observe quietly, report late, or not at all.
They blend into the background of natural spaces. If Atlas is such a machine, it is exactly what a cautious civilization would deploy in a dark forest. This raises an unsettling thought. Perhaps we are already surrounded by such probes.
Perhaps they are constantly passing by undetected because they look like comets and asteroids. Only now, thanks to advanced research, are we beginning to notice them. Each object we discover is discussed, explained, catalogued as an anomaly, but a natural one.
This is how camouflage works. The dark forest does not require that there be no one. It requires only that those who are there hide. Atlas, in its silence and ambiguity, may be a testament to this rule.
Some argue that the dark forest is too pessimistic. They point out that the silence could be explained by the natural rarity of life or by the limitations of our instruments.
They suggest that civilizations may not fear predators at all, would simply find no reason to signal. But the pessimistic model remains compelling because it explains both the absence of signals and the persistence of anomalies.
It suggests that what we call coincidence is actually strategy. It suggests that what we call natural visitors may be observers in disguise. If so, Atlas is no exception.
It is just a data point in a much larger picture that we are only beginning to comprehend. The worst-case scenario in this framework is not invasion or annihilation, but the realization that the galaxy is filled with life we will never hear.
That every star we see may be home to civilizations older and wiser than us. All of them are silent. All of them are hidden. All of them fear predators we cannot even imagine. Objects we dismiss as comets may be their tools.
The silence we interpret as absence may be their greatest strength. To live in such a galaxy is to live in ignorance, not because we cannot detect others, but because they will not allow themselves to be detected. For humanity, this scenario creates a dilemma.
Broadcast and risk exposure, or follow the rule of silence and hide in turn. So far, we have done both. We send radio waves into space, broadcasting our presence whether we intend to or not.
Yet, we also debate whether to send deliberate messages, fearing what response they might bring. The presence of Atlas exacerbates this dilemma. If this is a cloaked probe, then it suggests that the others already know we are here.
Our silence will no longer protect us. If it is natural, then its silence still serves as a reminder that survival may require restraint. Either way, the lesson is the same. In a dark forest, the loudest species may not survive for long.
Consider the implications. What if Atlas is not silent at all, but is signaling in ways we cannot detect? Perhaps its emissions are spread spectrum, indistinguishable from noise unless you know the code. Perhaps its signals are narrowly focused, aimed only at a specific point in the galaxy, invisible to us. Or perhaps its communication is not electromagnetic at all, but something we do not yet understand. Gravitational waves, neutrinos, quantum channels. To us, the silence remains.
To the one it speaks to, the message is clear. In a dark forest, communication itself may be layered and camouflaged. There is another dimension to it. If probes like Atlas exist, they could not only observe, but also warn.
They could act as alarms, signaling the emergence of civilizations that risk breaking the silence. Humanity, with its leaky radio waves and attempts to communicate with extraterrestrial intelligence, may already have been noticed.
Atlas's arrival may coincide with our crossing of a threshold, a point where our signals have become impossible to ignore. If so, its presence is not accidental. It is a response, not an attack, not a contact, but an observation caused by our own noise. This possibility is as humbling as it is frightening. The irony is that we will never know which interpretation is correct. Silence provides no answers. We listen and hear nothing. We speculate and cannot confirm.
Atlas passes, leaving us with data that matches both natural patterns and disguised intentions. This ambiguity is itself a kind of silence that speaks louder than any transmission. It tells us that the truth, whatever it may be, remains hidden, whether by nature's indifference or by intelligent design. Ultimately, the dark forest hypothesis forces us to look at Atlas differently.
Not as an anomaly to be solved, but as part of a larger pattern of silence. If the galaxy is indeed filled with hidden sentries, then Atlas is the only one we've noticed. Its silence is not an absence, but a strategy.
Its camouflage is not a mistake, but survival. The worst-case scenario is that this pattern is real and that we'll never escape it, that every interstellar visitor will look natural, act natural, and leave us baffled.
That we'll never hear voices, because the galaxy decided long ago that silence is the only way to live. Atlas retreats into the night, still silent. We cannot know whether this silence is natural or deliberate.
We cannot know whether it is the silence of ice or the silence of intent. All we can do is wonder whether we have glimpsed in the dark forest one of its silent hunters or one of its wary survivors.
When astronomers and philosophers talk about the Great Filter, they mean an invisible barrier that might explain why the universe seems so silent. If life is common, and intelligence must arise many times among billions of stars, then why don't we see signs of it everywhere?
The Great Filter is one answer. The newsroom presents. At some point along the path from chemistry to civilization, there is a threshold so difficult, so unlikely, or so dangerous that few will ever cross it. Some believe we have already passed it.
Others fear it lies ahead, but few ask what it would look like if it were not an abstract concept, but something real, something visible, something drifting in our skies.
The appearance of the three Atlas objects forces us to wonder whether the Great Filter is merely a theoretical concept. It may be a visitor. It may be right at our doorstep. The filter could take many forms. It could be an ecological factor, a chemical improbability that makes the emergence of life exceedingly rare. It could be a biological factor, the tendency of evolution to stagnate before it achieves intelligence. It could be a social factor, a flaw in civilizations that leads them to self-destruct before they can expand between the stars. But there is another possibility, far more disturbing, that the filter is external, imposed from the outside.
Civilizations that become loud enough to be noticed do not survive, because someone or something is making sure that they do not. If so, probes like Atlas may not be explorers or archivists, but instruments of the filter itself.
This idea does not imply a collision or an invasion. The Great Filter need not appear in dramatic form. It may operate quietly, unnoticed, through surveillance and subtle intervention. Perhaps civilizations that make themselves known are cataloged, studied, and tracked.
Perhaps something happens when they cross certain thresholds. Then the galaxy's silence may not be natural, but orchestrated. We cannot hear others because those who have spoken have been silenced.
If Atlas is part of this mechanism, we are not looking at a random comet. We are looking at a checkpoint, a reminder that the galaxy is not empty, but regulated.
This idea is hard to swallow because it paints a universe less welcoming than we imagine. We like to think about exploration, about meeting others, about joining a community of civilizations. The threshold filter model replaces this hope with caution.
It tells us that the very act of discovering Atlas, of discussing its nature, may be part of a test we cannot see. It suggests that what appears to be a scientific discovery may actually be surveillance. The probe does not need to act now.
He only has to watch, wait, decide whether we will pass or not. This interpretation is made more acute by the passage of time. Humanity has only just begun to detect interstellar visitors.
Our leakage of radio signals into space has been spreading for less than a century. Our digital signatures, our artificial satellites, our global networks are barely older than a human lifetime. If there was a moment when we could attract attention, it is now.
And at this very moment, just as our technology is awakening, we see Oumuamua, then Borisov, then Atlas. Coincidence? Perhaps. Or a timetable, a series of probes passing through us to confirm which species have begun to ascend, which are ready to be filtered.
What form would such filtering take? It would not necessarily mean annihilation. It might mean containment, ensuring that young civilizations never venture beyond their stars. It might mean containment, subtle interventions that derail progress.
It might mean cataloging, deciding who gets to go and who gets to stay. Or it might mean something we cannot even define, an outcome beyond our comprehension.
The great filter might not be a single event, but a process that repeats itself across the galaxy, invisible to those who have already been silenced. The silence we observe might not be a secret at all, but a testament to its success. Atlas, in this light, is more than an anomaly. It is a symbol. It embodies the possibility that the galaxy is structured not by chance, but by surveillance. Its speed ensures that it cannot be caught. Its coma hides its core. Its silence conceals its intent. Every feature makes sense to a machine designed not to communicate, but to observe. If the great filter operates through probes, they must appear natural, unremarkable, deniable.
They must be ambiguous enough that civilizations explain them even as they study them. This is how control is maintained through uncertainty. The worst-case scenario is not that Atlas destroys us.
The worst-case scenario is that Atlas proves that we are already inside a controlled system, that the galaxy is not an open frontier, but a controlled forest, where the rules are not enforced by chance, but by long-standing design.
To discover this, we must recognize that our fate is not entirely in our own hands, that survival depends not only on our actions, but on whether we are allowed to. This is what is meant by the great filter being at our doorstep. And yet, there is another way to look at this question. Perhaps probes like Atlas are not powers, but warnings. Perhaps they are reminders of the fragility of survival, of the hostility of the universe, that the real filter is not imposed from without, but experienced from within.
Radiation, collisions, supernovae, black holes, all are dangers enough. Perhaps Atlas is telling us that survival requires more than luck, that we must plan, adapt, and endure just like it. In this interpretation, the filter is not an external judgment, but a cosmic reality.
To survive is to defy the odds, and the existence of Atlas is proof that survival is possible. But the ambiguity remains. We cannot know which interpretation is true.
All we know is that this object is here and now, visible in our sky.
Its chemical composition is out of place. Its speed defies explanation. Its origins are rooted in an ancient, thick disk older than our world. It carries silence as its signature, and it appears just as humanity is becoming capable of noticing it.
This combination is enough to make one wonder if there is an answer at all. The Great Filter has always been a theoretical concept, a way to explain absences. But what if absence is not absence at all?
What if the silence is active, the result of a choice made long before us? What if every interstellar visitor is a messenger of that silence, a subtle reminder that we are not alone, but that being seen does not mean being wanted?
Atlas forces us to confront this possibility. Its presence makes the abstract tangible. Perhaps the filter is not so far away. Perhaps it is already here. And so Atlas continues its flight, heading outward, leaving us with data and speculation. We debate its nature.
We publish our models. We convince ourselves that it is just a comet. But doubt remains, because in that doubt lies a darker possibility, that the Great Filter is not in our past or our future, but is already at our door.
Atlas, silent and swift, may be the first knock we have heard. When we look at the three Atlases, we see a tiny visitor silhouetted against the blackness of space, with its faintly flickering tail, its predictable trajectory, its fleeting presence.
We see dust and ice, a chemical fingerprint, and orbital arc. But behind those numbers lurks a deeper question. If this object is not natural, or even if it is, what is it? Is it just debris?
Or is it something more? A relic not just of a star system, but of the intelligences that once existed there. When we think of probes or cloaking, we are also thinking of civilizations.
And if Atlas is in some way artificial, it may not belong to living things. It may be the ghost of a long-gone civilization. The galaxy is old. Our own solar system has been around for 4.5 billion years.
Yet the Milky Way is more than twice that age. The thick disk from which Atlas may have emerged dates back 10 or 12 billion years. Entire cycles of creation and destruction could have unfolded in that time.
Civilizations could have arisen, flourished, expanded, and vanished before the sun was even born. Their technologies could have survived, drifting through space long after their creators had vanished.
Atlas could have been one such remnant, a silent machine carrying not just tools but also memories, the last traces of beings that are no more. What is troubling about this idea is its plausibility.
We know from our own history how fragile civilizations can be. Empires rise and fall over centuries. Languages disappear. Cultures fade. Knowledge is lost. We project this fragility onto cosmic timescales and realize how unlikely it is for any civilization to last billions of years.
But technology persists differently than biology. Machines can outlive their creators. Probes can travel long after their builders have turned to dust. So the galaxy may be populated not by living things, but by their creations.
Every interstellar object we discover may be more than just ice. It may be a monument to those who came before us, who tried to travel beyond their stars, who left behind artifacts mistaken for comets. The ghost hypothesis is both comforting and terrifying.
comforting because it suggests that we are not alone, that others once existed, that intelligence is not unique. Terrifying because it also suggests that extinction is inevitable. If Atlas is a ghost, then its creators are gone.
The newsroom presents an analysis of the silence in space and its possible interpretations, considering what the discovery of objects like Atlas might mean and what conclusions we can draw about the fate of civilizations. Their silence is not a strategy, but a finality.
In that case, we will encounter not explorers, but tombstones. And the worst-case scenario is that our own future is written in bears, that we too will leave behind relics that will be mistaken for natural objects, silent witnesses drifting through the galaxy long after we have disappeared.
Consider what it would mean for a probe to outlive its civilization. Without contact, without maintenance, without upgrades, it would be autonomous by necessity. Its mission would continue until its systems failed, until time had erased its functions, until cloaking became indistinguishable from decay.
But if it was designed to endure, if it was built to last through cosmic eons, it might still function, following instructions written billions of years ago. Maybe it no longer mattered that its creators were gone. The mission may be all that remains.
Atlas may be a ghost, not just in a symbolic sense, but in practice. A machine still carrying out commands from masters who no longer exist. If so, what commands will stand the test of time? Observation is easy.
Measuring radiation, cataloging atmospheres, recording chemical compositions. These tasks require no contact, require no decisions. They can be repeated indefinitely. The ghost probe will wander, collecting and perhaps transmitting data, though to no one. Its signals may go unanswered, its data never received.
It will become a ritual, a function without an audience, a persistence without a purpose. And yet, from our perspective, it will still seem alive, will still seem purposeful.
The frightening part is that its activities will look the same whether its civilization has flourished or perished. We will not be able to tell one from the other. This uncertainty deepens the mystery.
If Atlas is a natural object, then it is the survivor of a cosmic violence. If it is artificial, it may be the survivor of a civilizational violence, an extinction. In any case, survival is its defining feature. But survival of what?
Of matter, of mission, of memory. If the galaxy is peopled by such ghosts, then each interstellar visitor is more than an anomaly. It is history incarnate, proof of civilizations, even if we never learn their names.
The ghosts pass us by without a word, and we do not recognize them. One might argue that ghosts are only metaphors, that machines cannot carry a spirit, only a function. But even a function is enough.
A probe like Atlas, if artificial, is not just a machine. It is a remnant of the minds that thought and planned and built. It is their continuation, however feeble, through a time they themselves could not have witnessed.
When we look at it, we may be looking directly at the work of a mind 10 billion years ago. That alone is enough to make it a ghost, an echo of a presence, a whisper of something that is no more.
The thought grows darker when combined with the great filter. Perhaps civilizations do not survive,
but their machines do. Perhaps the galaxy is not empty, but littered with remains. Ghost probes drifting and cloaked. Fragments of once great species reduced to silence.
We mistake them for comets, but they are memorials. If so, then the future is clear. We too will leave behind our voyages, our pioneers, our satellites drifting endlessly after our disappearance.
And if another civilization finds them, they will ask the same question we now ask of Atlas. Was it natural, or was it a ghost? The worst-case scenario here is not an encounter or an invasion, but a realization
that the galaxy is filled with civilizations, but only in the past tense. That intelligence often appears, but never survives. That the silence we hear is not an absence, but an aftermath.
Atlas, then, is not a threat, but a reminder, a ghost passing by to show us what awaits us if survival proves impossible. Its very presence is a warning, silent but powerful. Others have been here and they are gone. There is another possibility, however.
Ghosts may not be passive. If a probe like Atlas is still functional, it can still exert influence. It can seed life, spread chemicals, reshape worlds in the ways its creators intended.
If so, the ghosts of civilizations past are not just memories, but participants, shaping the galaxy long after they are gone. In that sense, they are not gone at all. They live through their machines, their legacy etched into every system they pass.
Perhaps even life on Earth owes its origins to such interventions seeded by ghost probes long forgotten. The irony would be profound if our own existence were the product of civilizations that did not survive.
We are an extension of them without even knowing it. But, as always, ambiguity prevails. We cannot know whether Atlas is just ice or something more.
We cannot be sure whether it is a natural survivor or an artificial ghost. All we can do is wonder. And it is precisely this wonder that makes it so compelling.
For ghosts are defined not by their presence, but by our inability to explain them. They are what remains when explanations fail. Atlas fits this definition all too well.
And so it continues on its way, disappearing from our instruments, leaving us in silence and contemplation. If it is a ghost, then it has served its purpose. Not to communicate, not to act, but simply to remind us that we are not the first to ask questions. The galaxy is old. Civilizations come and go. Their remnants drift forever through space. Atlas could be one of them.
An ambassador, not of life, but of its inevitable fragility. The ghosts of past civilizations are out there in space, and one of them may have just flown past our world.
In the vast expanses of space, where the stars shimmer like diamonds on a velvet canvas, there are countless secrets waiting to be revealed. Each galaxy, each nebula, each quasar is just a small piece of a huge puzzle that humanity has been trying to assemble throughout its history.
We, like specks of dust lost in this cosmic ocean, strive to understand our place in it, unravel the laws that govern its movement, and perhaps find answers to the eternal questions about the origin of life and its future.
In this pursuit, we point our telescopes to the most distant corners of the universe
analyze the smallest particles of matter, and develop increasingly complex theories to get closer to understanding the truth.
And every time we take a new step forward, we realize how much more remains to be learned, how deep and mysterious is the mystery we are trying to unravel, but it is precisely this ignorance that drives our progress, forcing us to search, explore, and dream of new discoveries that may await us around the next turn of the cosmic spiral.
When scientists study comets, they often see them as more than just frozen relics of planetary birth. They see opportunity. Comets carry water, organic matter, and complex molecules. They preserve the chemistry of ancient disks in deep freeze, delivering these compounds when they collide with young planets. This has long inspired the theory of panspermia, the idea that life, or the building blocks of life, travels through space, spreading via collisions, drifting dust, and icy messengers.
If 3 atlases is a natural formation, it could be one such messenger, a carrier of chemicals from a star system older than our own, now spewing gases into the inner solar system. That thought alone is profound. But the speculation doesn't end there.
For if comets can deliver life, they can also deliver death. Panspermia may not be a gift, but something worse. At its most optimistic, panspermia suggests that life is universal.
That the molecules of biology, the seeds of cells, drift from star to star, carried across light years by survivors like Atlas. The vast space, like a huge ocean, holds countless secrets and mysteries in its depths. The stars, like lighthouses, point the way to new discoveries, and the planets, like islands, beckon with their unexplored landscapes. Humanity, like a brave sailor, sets off on this exciting journey to unravel the secrets of the universe and find its place in this vast space.
With each new step, with each new discovery, we come closer to understanding how our universe is structured, how life originated, and what opportunities it conceals.
But at the same time, we realize that space is not only a source of knowledge and inspiration, but also a potential threat. Comets and asteroids, like wandering ghost ships, can collide with our planet, causing catastrophic consequences.
Studying these celestial bodies and developing ways to protect against them is one of the most important tasks of modern science. We must be prepared for any challenges that space throws at us and continue to explore it to ensure the future of our civilization.
A young planet receiving such material could get a head start on the evolution of biology. Life might not need to arise anew in every system. It might only need to take root when the right chemistry emerges.
If true, we might all share a common origin, not just on Earth, but throughout the galaxy. The aDNA that builds us might have relatives on worlds around distant stars. Then, Atlas would be more than a curiosity. It would be family.
But panspermia has darker implications. If life can spread, so can disease. Microbes can survive astonishing extremes: vacuums, radiation, extreme cold. Earth's extreme environments display resilience we once thought impossible.
If organisms can survive being blasted into space by ensconced in rock or ice, panspermia might carry more than building blocks. It might carry active biology. And if so, then every interstellar visitor is more than just chemistry. It's a risk,
Atlas could theoretically carry organisms unknown to Earth, adapted to conditions we can't imagine, capable of disrupting ecosystems in ways we can't predict. The same machinery that spreads life could also spread extinction.
Imagine a vast cosmos dotted with billions of stars, each a sun with planets orbiting it. Some of these planets might harbor life that is completely different from our own.
It might be based on different chemical elements, come in different shapes and sizes, and live in conditions that seem unimaginable to us. But what if that life not only exists, but can travel between the stars?
What if microbes, bacteria, and even more complex organisms can survive in the vacuum of space, protected from radiation and extreme temperatures inside meteorites and comets? Then our universe becomes not just a vast space, but a giant network that links all living things together.
And every time a comet passes Earth, it may carry with it not only the building blocks of life, but also the potential for danger, new diseases, new species that could upset the delicate balance of our ecosystem.
We must be prepared for this, explore space, and develop ways to protect ourselves from possible dangers in order to ensure the future of our planet and preserve life in all its diversity.
For this reason, scientists debate whether panspermia is a blessing or a curse. Some suggest that this is how life on Earth began, seeded by organic-rich comets. Others caution that if life can spread, it can also suppress.
If civilizations exist, they might exploit this principle deliberately. Instead of sending ships, they could send seeds, genetic payloads designed to modify the environment, replicate, and dominate. Such strategies would be cheaper and more durable than fleets.
A probe disguised as a comet could carry spores, microbes, or engineered replicators, silently releasing them into planetary systems. To us, it would look like natural outgassing. To them, it would be seeding.
The idea that Atlas might be such a vehicle is hard to dismiss entirely. Its unusual chemistry already defies expectations. Its survival over billions of years suggests a longevity beyond chance. If it is artificial, its purpose may not be just observation.
It may be dispersal. In the depths of space, where stars shimmer like diamonds on black velvet, lie not only unsolved mysteries, but also potential threats.
As explorers of the unknown, we strive to unravel the secrets of the universe. But we must remember that with new knowledge comes responsibility. Panspermia, the theory that life spreads through space, may be a curse as well as a blessing.
If life can travel between stars, then it may also carry diseases that can wipe out entire civilizations. We must be prepared for this, develop methods to protect ourselves from possible threats, and remember that our actions may have far-reaching consequences for the entire galaxy.
After all, in space, as in life, everything is interconnected, and even a small event can lead to unpredictable results. A single object, drifting undetected, can carry the seeds of biology through systems, spreading life or changing it, panspermia, or worse.
Evolution driven not by chance, but by deliberate engineering. Which brings us to the question of intent. In the vastness of space, where the stars shimmer like a scattering of diamonds on black velvet, not only comets and asteroids drift,
but also seeds of life that can change the course of evolution of entire planets.
These seeds, like messengers from distant worlds, can carry not only building blocks for new forms of life, but also genetic codes that can rewrite existing ecosystems. And who knows what intentions are hidden behind these space wanderers?
Perhaps this is an accidental spread of life, or perhaps a carefully planned action to populate the galaxy with new forms of life, created by intelligent beings striving for expansion and dominance.
We must be prepared for any scenario and study space to understand what dangers and opportunities it conceals. After all, the future of not only our planet, but the entire universe depends on our actions. Natural panspermia is indifferent. Life spreads where it can, surviving by chance. But artificial panspermia introduces design. Imagine a vast expanse of space, dotted with myriads of stars and planets. Comets and asteroids drift through this splendor like cosmic wonders, carrying the seeds of life.
But what if there is more to this process than chance, but intelligent design? What if someone is deliberately spreading life throughout the universe, creating new worlds and reshaping existing ones?
This raises important questions about our role in the cosmos and whether we are prepared to meet other civilizations. We must be open to new knowledge and possibilities, but also cautious and mindful of the dangers that lie ahead.
After all, space is not only a source of inspiration and discovery, it is also a place where unknown threats may lurk. Imagine that Atlas carries not just random molecules, but carefully selected ones.
What if the organic substances it expels are not the remnants of formation, but instructions encoded in chemistry? Such a probe could alter the course of worlds, implanting traits, directing evolution, shaping ecosystems. It would be gardening on a galactic scale. But it would also be manipulation. If Earth were seeded this way, our biology might not be entirely our own. We might be products not of chance, but of an ancient program, written long ago, still running through relics like Atlas.
A darker version of this possibility is weaponization. Panspermia need not bring life. It could bring sterility. The probe could release chemicals that destroy DNA, poison the atmosphere, or sterilize surfaces. This is not far-fetched in principle.
Microbial warfare exists even on Earth, where one species evolves to suppress another. On a cosmic scale, such strategies might be deployed not as war, but as filtering, ensuring that emerging civilizations never advance, that young biospheres are never threatened.
If so, then interstellar visitors are not neutral messengers. They are overseers. Atlas may be one of them, carrying not life, but erasure, disguised as natural life, acting as a monitor.
Skeptics will argue that such ideas are speculative to the point of paranoia, and they are right. There's no evidence that Atlas carries anything more than carbon dioxide and dust. But absence of evidence is not evidence of absence. The uncertainty remains.
We cannot see into its core. We cannot intercept its payload. We cannot know whether what it spews out is accidental or designed. We can only entertain the possibility. And in that assumption, the worst-case scenario is ingrained. Again, consider the numbers. Atlas comes from a thick disk, a population older than Earth itself. If it carries biology, it may carry biology from a time before our planet existed. What would such biology look like? Would it resemble anything we know? Would it survive here?
Or would it conflict with our own ecosystems, rewriting them in ways we cannot predict? The idea of panspermia often fills us with fascination, but it should also fill us with caution.
To accept material from an object so ancient is to invite something alien into our world. And yet, it may already have happened. Comets have collided with Earth countless times throughout its history. The impacts bring not just destruction, but chemistry.
Some argue that the ingredients for life itself arrived this way, delivered by icy messengers billions of years ago. If true, panspermia is not a theory. It is our origin. We are already a product of it, which raises another disturbing possibility.
That panspermia is not random at all, but orchestrated. That life across the galaxy is being seeded deliberately, guided by a program written not by chance, but by civilizations long gone. If so, Atlas is not the first seeder we have encountered.
It is only the latest. The worst-case scenario here is multi-layered. If Atlas is natural, it may still carry organic matter that will change our understanding of life. If it is artificial, it may carry design, biology designed to seed or suppress.
Either way, it confronts us with the fragility of our assumptions. We imagine life as our own, Earth as unique, biology as local. But Atlas reminds us that the galaxy may be far more connected and far more dangerous than we want to believe.
For humanity, the lesson is clear. We cannot assume that interstellar visitors are neutral. We cannot assume that panspermia is only a blessing. We must consider the possibility of something worse.
Because once an object passes, once it sheds its chemistry, once it scatters its dust, we have no defense. We cannot filter space. We cannot intercept every visitor. We are naked, and nakedness means risk.
Whether it is the beginning of life or the end of life. And so Atlas goes on its way, dispersing carbon dioxide, gloating faintly against the night. To most, it's just a comet, another icy body burning briefly before vanishing.
But to those who ponder, it's something more. A potential messenger, a potential threat, a potential ghost, panspermia, or worse. We can't know. All we can do is watch it pass and wonder what it leaves behind.
When people imagine an invasion from the stars, they imagine fleets of ships, blinding lights in the sky, weapons far beyond our understanding. The stories we tell ourselves tend toward the spectacular, because it is the spectacular that inspires fear and awe.
But in reality, an invasion need not be dramatic. It need not arrive in force or in flames. It could arrive silently, unnoticed, carried inside motes of dust, riding on the tail of comets, spread not by armies, but by chemistry.
It could arrive as microscopic seeds, particles too small to see, too simple to recognize, drifting through the atmosphere and the oceans without resistance. If so, then silent invasions may already have happened, not through conquest, but through the quiet persistence of biology, or what only appears to be biology. Atlas, with its blanket of gas and dust, is the stage for this possibility. We know that comets shed material as they approach stars, releasing plumes of volatile compounds that spread into the surrounding space.
The Earth itself has passed through cometary debris countless times.
The particles burn up like meteors in our skies, some surviving to reach the ground. If Atlas carries more than dust, it too may be capable of dispersal.
And if what it carries is not just chemistry, but engineered microscopic seeds, then we are faced with a form of contact for which we are not prepared. The microscopic seed need not be alive in the sense that we define life.
It could be self-assembling molecules, fragments that replicate under the right conditions. It could be nanostructures designed to activate when exposed to certain kinds of energy. It could be something between biology and machine. Too alien for us to classify.
Our instruments would probably register them as dust or noise, dismissing them as pollution. However, once inside the planetary environment, they could grow larger, taking root in the soil, air, or water, changing ecosystems quietly, unnoticed over generations.
Replacing what exists with something else, gradually, unnoticed, invisibly. It doesn't matter whether the other is biology, nanotechnology, or chemistry. What matters is that it takes root where it is not wanted, and once it has taken root, it cannot be destroyed.
A civilization may never know it has been invaded until its world no longer resembles what it once was. Skeptics will point out that we have no evidence of such spread. They are right, but the lack of evidence is precisely the point. Stealthy invasions succeed precisely because they remain undetected. If Atlas is natural, it doesn't fit into any narrative of malevolence. If it is artificial, its effectiveness lies in its ambiguity.
We can dismiss it as a comment, as debris, as an anomaly, and it succeeds in this denial. The microseed invasion does not require us to notice. In fact, it depends on us not noticing. This possibility raises uncomfortable questions about our own actions. When we send probes beyond Earth, when we launch spacecraft that may one day traverse interstellar space, are we also carrying microseeds? Unintentionally, perhaps, but microbes cling to surfaces, survive sterilization, endure extremes.
Our machines may already be carrying Earth life outward, inadvertently seeding other systems. From another perspective, we may be silent invaders, unaware of the consequences of what we release. If we can do this without intent, what might others achieve if they did?
The ambiguity of Atlas heightens this worry. Its speed, its chemistry, its survival, its silence, all of this can be explained naturally, but it can also be explained strategically.
A probe, disguised as a comet, shedding dust that carries seeds, fits all too well with what a cautious, long-lived civilization might deploy. It requires no confrontation, no risk, no communication. It is an invasion without contact, a spread without war, a victory without awareness.
This is the true nightmare of microseeds and silent invasions. They succeed not because they overwhelm, but because they are ignored. The galaxy may already be filled with such invasions.
Life itself may be a product of them, spreading not by chance but by ancient design. Our biology may not be ours alone, but the accumulation of countless scatterings over billions of years.
The Atlas may then not be unique, but typical, one of many seeds drifting endlessly. If so, then the invasion is not a future speculation, but a past reality. We are already products of it, shaped by it, unable to separate ourselves from it.
The line between natural panspermia and deliberate seeding blurs until it disappears. What we call biology may already be an invasion, long since completed. And yet the worst case gets even darker. Because if Atlas carries microseeds, they may not be designed to coexist.
They may not be biology as we know it, but something designed to replace biology entirely. Nanostructures that consume organics, self-replicators that disassemble DNA, chemistry that operates on principles alien to ours. To us, they would be invisible until they were everywhere.
By the time we noticed, it would be too late. Silent invaders succeed not because they are fast, but because they are patient, and the galaxy has patience in abundance.
As Atlas moves across our skies, dropping its veil, drifting alongside its arc, we cannot know what it carries. For most, it will always be a comet, unusual but natural. For some, it is something else. A messenger, a ghost, a probe, a threat.
Whether panspermia or, worse, whether natural or engineered, whether harmless or invading, ambiguity is the essence. Silent invasions thrive when debate replaces certainty, when doubt prevents action, when the object is dismissed as an anomaly while it does its job. Atlas, in its silence, may already embody that principle.
And so we watch it pass, knowing that if it carries seeds, they are already scattered. If it is an invasion, it is already silent. The object leaves us with only questions.
And questions may be the only proof we will ever have, because in the galaxy, the loudest invasions are the easiest to resist. The silent ones are the ones that endure. Every discussion of the three atlases ultimately returns to the same possibility.
If it is just ice and dust, then it is nothing more than a curiosity of nature, strange but natural, fleeting but harmless. If it is more, if it is artificial, if it is engineered in some way, then its role is most likely not to act but to observe.
It does not need to announce itself or intervene directly. It does not need to land or signal. Its function could be as simple as observing, moving silently through our system, gathering information, and then disappearing into the darkness. This is the possibility that haunts us most, because if Atlas is observing, the question becomes inescapable. What does it see? To answer that question, we must first imagine the perspective of such an observer. From his position in interstellar space, he would not see Earth as we do. He will see a planet glowing faintly in reflected sunlight, shrouded in a thin atmosphere, riddled with electromagnetic noise leaking into space.
His sensors will measure the chemical composition, scaling for oxygen, nitrogen, methane, carbon dioxide. From these capsules alone will he know that Earth is not barren.
He will recognize the imbalance, the oxygen levels maintained only by biological activity, the methane present despite its tendency to decay. That single signature, even without the radio leak, would be enough to detect life.
But Atlas, if it is watching, will see more than life. It will see civilization. Our radio signals, however faint, travel about a century into space. They are faint, yes, but not non-existent.
To sensitive instruments, the glow of radio, television, radar, and satellites forms a detectable halo. Earth is no longer silent.
We have given ourselves away by leakage.
A probe passing by now at the right distance might confirm what natural spectra already suggest, that this is not just a living world, but a world where intelligence has emerged. If Atlas is an observer, it already knows this.
What's troubling is what else it might notice. Our atmosphere contains traces of pollution. Chlorofluorocarbons, industrial chemicals, isotopes from nuclear activity. These are not natural markers. They are signs of technology, signs that a species here has mastered industry and energy.
Even without listening to our transmissions, an observer could read this from the air. The Earth reveals itself through chemistry. If Atlas is measuring, it sees not just biology, but industry. Not just life, but civilization. It sees us. And what would it conclude?
That depends on intent. A neutral observer might simply catalog. It would add us to a database of worlds, noting our stage of development, comparing us to others, measuring our trajectory.
An analytical observer can assess risk by calculating whether we are dangerous, whether we are likely to expand, whether we will break the galactic silence. A strategic observer can do more by considering whether to intervene. From our perspective, we cannot know which.
All we can know is that if it is observing, it will not miss the obvious. Earth glows with signs that no natural world can produce. Some argue that this is paranoia, that even if probes exist, they do not care about us.
But history shows that the act of observation is never neutral. To observe is to value knowledge. To value knowledge is to plan how to use it. If Atlas is indeed observing, then we are part of its target.
The only question is whether we are the object of its curiosity, the object of its study, or the object of its strategy. The difference between these outcomes is enormous, but from our perspective, they all look the same. Silence.
The problem is compounded when we consider scale. If Atlas is one of many, then Earth may have been observed before. Perhaps many times, perhaps long before we had the capacity to notice.
The first observers would have seen a planet of forests and oceans, but no machines. Later observers might have seen the first humans, their fires burning low, their numbers few. Now the observer sees cities, satellites, networks, signals.
From his perspective, Earth is a rapidly changing world. Civilization arose in the blink of an eye, and with it, risk. That sudden change would be unmistakable. Atlas, if it were observing, would know that something had changed here.
In a sense, the worst-case scenario is not just that we are being observed, but that we are being judged. Observation is rarely passive. It often leads to judgment.
If it is more than that, if it is artificial, if it is designed in some way, then its most likely function is not to act, but to observe. It need not announce its presence or intervene directly.
It would not need to land or signal in any way. Its function could be simple: to observe, to move silently within our system, gather information, and then disappear into the darkness.
This possibility is especially troubling because if Atlas is observing, the inevitable question arises: what is it seeing? To answer this, we must first imagine the perspective of such an observer. From his position in interstellar space, Earth would not look as we see it.
He would see a planet faintly glowing in reflected sunlight, surrounded by a thin atmosphere, with electromagnetic noise escaping into space. His sensors would measure the chemical composition, scanning for oxygen, nitrogen, methane, and carbon dioxide.
Only from these gases would he know that Earth is not lifeless. It will detect a state of disequilibrium, oxygen levels maintained only by biological activity, and methane present despite its tendency to decay.
This alone, even without taking into account the radio leaks, will be enough to detect life. But Atlas, if it is observing, will see not only life, but civilization. Our radio signals, though weak, extend into space for about a century.
Yes, they are weak, but they are not absent. To sensitive instruments, the glow of radio, television, radar, and satellites forms a detectable halo. Earth is no longer silent. We have given ourselves away by these leaks.
A probe passing by at the right distance might confirm what natural spectra already indicate. This is not just a living world, but a world in which intelligence has arisen. If Atlas is an observer, it already knows this.
The worrying thing is what else it might notice. There are traces of pollution in our atmosphere, chlorofluorocarbons, industrial chemicals, isotopes from nuclear activity. These are not natural markers. They are signs of technology, signs that a species on Earth has mastered industry and energy.
Even without listening to our broadcasts, an observer can get this information directly from the atmosphere. The Earth reveals itself through its chemical composition. If Atlas is measuring, it sees not just biology, but industry, not just life, but civilization. It sees us.
And what will it conclude? That depends on its intentions. A neutral observer might simply catalog. It would add us to a database of worlds, note our stage of development, compare us to others, and measure our trajectory.
An analytical observer might assess risk, calculating whether we are dangerous, whether we are likely to expand, and whether we will break the galactic silence. A strategic observer might go further, considering whether intervention is necessary.
From our perspective, we cannot know which of these options is true. All we can know is that if it is observing, it will not miss the obvious. Earth glows with signs that no natural world can produce.
Some argue that this is paranoia, and that even if probes exist, they do not care about us. But history shows that the act of observation is never neutral. To observe is to value knowledge. To value knowledge is to plan how to use it.
If Atlas is indeed observing, then we are part of its target. The only question is whether we are the object of its curiosity, the object of its study, or the object of its strategy. The difference between these outcomes is enormous.
But from our perspective, they all look the same: silence. The problem becomes even more complex when we consider scale. If Atlas is one of many, then Earth may have been observed before, perhaps many times, perhaps long before we had the capacity to notice.
The first observers would have seen a planet of forests and oceans, but no machines. Later observer might have seen the first humans, their campfires, dimly glowing, and a smattering of numbers. Now the observer sees cities, satellites, networks, and signals.
From his perspective, Earth is a rapidly changing world. Civilization arose in the blink of an eye, and with it came risk. That sudden change would be unmistakable. Atlas, if it were watching, would know that something had changed here. In a sense, the worst-case scenario is not just that we are being watched, but that we are being judged. Watching is rarely passive. It often leads to judgment.
If it were more than that, if it were artificial, if it were somehow engineered, then its role would likely be not to act, but to observe.
It would not need to announce itself or intervene directly. It would not need to land or signal. Its function could be as simple as observing, passing silently through our system, collecting information, and then disappearing back into the darkness. It is this possibility that remains the most serious, because if Atlas is observing, the question becomes inescapable. What is it seeing?
To answer that question, we must first imagine the perspective of such an observer. From his position in interstellar space, he would not see Earth as we do.
He would see a planet faintly glowing in reflected sunlight, shrouded in thin layers of atmosphere, dotted with electromagnetic noise leaking out into space. Its sensors would measure the chemical composition, scanning for oxygen, nitrogen, methane, carbon dioxide.
From these gases alone, it would know that Earth was not barren. It would recognize the imbalance, the oxygen levels maintained only by biological activity, the methane present despite its tendency to break down. That single signature, even without the radio signal leak, would be enough to reveal life. But Atlas, if it were watching, would see more than life. It would see civilization.
Our radio signals, faint as they are, extend out into space for a radius of about a century. Faint, yes, but not absent. To sensitive instruments, the glow of radio, television, radar, and satellites forms a detectable halo. Earth is no longer silent.
We have betrayed ourselves by leakage. A probe passing by now at the right distance might confirm what natural spectra already suggest, that this is not only a living world, but a world where intelligence has emerged. If Atlas is an observer, it already knows this.
What's worrisome is what else it might notice. Our atmosphere contains traces of pollution, chlorofluorocarbons, industrial chemicals, isotopes from nuclear activity. These are not natural markers. They are signs of technology, signs that a species here has mastered industry and energy.
Even without listening to our broadcast, an observer could read this out of the air. The Earth is revealing itself through chemistry. If Atlas measures, it sees not just biology, but industry, not just life, but civilization. It sees us. And what does it conclude?
That depends on the intent. A neutral observer might simply catalog. It would add us to a database of worlds, noting our stage of development, comparing us to others, measuring our trajectory.
An analytical observer might assess risk, calculating whether we are dangerous, whether we are likely to expand, whether we will break the galactic silence. A strategic observer might do more, considering whether intervention is necessary. From our perspective, we cannot know which.
All we can know is that if it observes, it will not miss the obvious. Earth glows with signs that no natural world can produce. Some argue that this is paranoia, that even if probes exist, they do not care about us.
But history shows that the act of observation is never neutral. To observe is to value knowledge. To value knowledge is to plan how to use it. If Atlas is indeed observing, then we are part of its target.
The only question is whether we are the object of its curiosity, the object of its study, or the object of its strategy. The difference between these outcomes is enormous, but from our perspective, they all look the same. Silence.
The problem is compounded when we consider scale. If Atlas is one of many, then Earth may have been observed before, perhaps many times, perhaps long before we had the capacity to notice.
The first observers would have seen a planet of forests and oceans, but no machines. Later observers might have seen early humans, their fires burning low, their numbers few. Now the observer sees cities, satellites, networks, signals.
From his perspective, Earth is a world in flux. Civilization has risen in the blink of an eye, and with it, risk. That sudden change would be unmistakable. Atlas, if it were watching, would know that something had changed here.
In a sense, the worst-case scenario is not just that we are being watched, but that we are being judged. Watching is rarely passive. It often leads to judgment.
If it is something more, if it is artificial, if it is somehow engineered, then its role is most likely not to act, but to observe. It need not announce itself or intervene directly. It need not land or signal.
Its function could be as simple as observing, moving silently through our system, collecting information and then disappearing into the darkness. This is the possibility that haunts us most. Because if Atlas is observing, the question becomes inescapable. What does it see?
To answer that question, we must first imagine the perspective of such an observer. From his position in interstellar space, he would not see Earth as we do.
He would see a planet faintly glowing in reflected sunlight, shrouded in thin layers of atmosphere, pockmarked by electromagnetic noise leaking out into space. Its sensors will measure the chemical composition, scanning oxygen, nitrogen, methane, carbon dioxide. From these gases alone, it will know that Earth is not barren. It will recognize the imbalance, the oxygen levels maintained only by biological activity, the methane present despite its tendency to decay. This single signature, even without the radio leak, would be enough to detect life. But Atlas, if it is watching, will see more than life. It will see civilization. Our radio signals, however faint, travel about a century into space. Faint, yes, but not non-existent.
To sensitive instruments, the glow of radio, television, radar, and satellites forms a detectable halo. Earth is no longer silent. We have given ourselves away by leakage.
A probe passing by now, at the right distance, might confirm what natural spectra already suggest, that this is not just a living world, but a world where intelligence has emerged. If Atlas is an observer, it already knows this.
What's disturbing is what else it might notice. Our atmosphere contains traces of pollution. Chlorofluorocarbons, industrial chemicals, isotopes from nuclear activity. These are not natural markers. They are signs of technology, signs that a species here has mastered industry and energy.
Even without listening to our broadcasts, an observer could read this out of the air. The Earth is revealing itself through chemistry. If Atlas measures, it sees not just biology, but industry. Not just life, but civilization. It sees us. And what will it conclude?
That depends on intent. A neutral observer might simply catalog. It would add us to a database of worlds, noting our stage of development, comparing us to others, measuring our trajectory.
An analytical observer might assess risk, calculating whether we are dangerous, whether we are likely to expand, whether we will break the galactic silence. A strategic observer might do more, considering whether intervention is necessary.
From our perspective, we cannot know which.
All we can know is that if it observes, it will not miss the obvious. Earth glows with signs that no natural world can produce. Some argue that this is paranoia, that even if probes exist, they do not care about us.
But history shows that the act of observation is never neutral. To observe is to value knowledge. Valuing knowledge means planning how to use it. If Atlas is truly observing, then we are part of its target.
The only question is whether we are the object of its curiosity, the object of its study, or the object of its strategy. The differences between these outcomes are vast, but from our perspective, they all look the same. Silence.
The problem is compounded when we consider scale. If Atlas is one of many, then Earth may have been observed before, perhaps many times, perhaps long before we had the capacity to notice.
The first observers would have seen a planet of forests and oceans, but no machines. Later observers might have seen the first humans, their fires low and few in number. Now the observer sees cities, satellites, networks, signals.
From his perspective, Earth is a rapidly changing world. Civilization arose in the blink of an eye, and with it, risk. That sudden change would be unmistakable. Atlas, if it were watching, would know that something had changed here.
In a sense, the worst-case scenario is not just that we are being watched, but that we are being judged. Watching is rarely passive. It often leads to judgment. Watching is rarely passive. It often leads to judgment.
If it is more than just observation, if the object is artificial or purposefully designed, then its primary function is probably not active intervention, but passive observation. Such an observer does not need to announce its presence or directly interfere with what is happening.
It does not need to land on the planet or send any signals. Its functionality may be limited to simply recording what is happening, moving unnoticed within our system, collecting the necessary information, and then disappearing into the darkness of space.
It is this possibility that is most troubling, because if Atlas is indeed observing, the question inevitably arises, what exactly is it seeing? To answer this question, we must try to imagine the point of view of such an observer.
Situated in interstellar space, it will not perceive the Earth as we do. It will see only a planet faintly shimmering in reflected sunlight, surrounded by a thin layer of atmosphere, with numerous electromagnetic interferences penetrating into space.
Its sensors will analyze the chemical composition, scanning the atmosphere for oxygen, nitrogen, methane, and carbon dioxide. From this data alone, an observer will be able to conclude that Earth is not a lifeless planet.
You will be able to detect the state of imbalance, the presence of oxygen maintained solely by biological activity, and the presence of methane, despite its tendency to decompose. Even these minor signs, without taking into account radio signals, will be enough to detect life.
However, Atlas, if it is really observing, will see much more than just signs of life. It will see an advanced civilization. Our radio signals, despite their weak power, spread through space over a distance of about 1 light century.
Yes, these signals are quite weak, but they still exist. For highly sensitive instruments, the radiation from radio, television, radar, and satellites forms a completely distinguishable halo. Earth is no longer silent. We have given ourselves away by leaking information.
A space probe passing at a certain distance would confirm what the natural spectra already suggest.
that this planet not only harbors life, but that it has evolved intelligence. If Atlas is an observer, it already has this knowledge.
But what else it might notice is more troubling. There are traces of pollution in our atmosphere. Chlorofluorocarbons, industrial chemicals, and isotopes from nuclear activity. These are not natural signs.
They are clear signs of technological advancement, evidence that this planet has evolved a species capable of harnessing industry and energy. Even without intercepting our transmissions, an observer could gain this information by analyzing the composition of the atmosphere.
The Earth reveals itself through its chemical elements. If Atlas is measuring, it is recording not only biological activity, but also industry. Not only life, but also civilization. It is seeing us. And what conclusions can it draw? That depends on its intentions.
A neutral observer might simply be collecting and cataloging information. It would enter our planet into a database of different worlds, note our current stage of development, compare us with other civilizations, and measure the trajectory of our development.
An analytical observer might assess potential risks by determining how dangerous we are, how likely we are to expand, and whether we will violate the cosmic silence. A strategic observer might go even further by considering whether intervention in our affairs is necessary.
From our perspective, we cannot know which of these scenarios is real. The only thing we know for sure is that if we are being observed, the observer will not miss the obvious. The Earth emits signatures that no natural object can produce.
Some argue that this is paranoia, that even if there are probes, they don't care about us. But history shows that observation is never neutral. To observe is to value knowledge. To value knowledge is to plan for its application.
If Atlas is indeed observing, then we are part of its design. The only question is whether we are objects of curiosity, objects of study, or objects of strategic planning. The differences between these options are vast.
But from our side, they all look the same. Silence. The problem becomes even more complex when we consider the scale of what is happening.
If Atlas is just one observer among many, then Earth may have been observed before, perhaps many times, perhaps long before we had the capacity to notice. The first observers would have seen a planet covered in forests and oceans, but without any machinery.
Later observers might have seen the first humans, their low fires, and a few numbers. Now, the observer sees cities, satellites, networks, and signals. From his perspective, Earth is a world in rapid change.
Civilization has emerged in the blink of an eye, and with it comes risk. This sudden change would not go unnoticed. Atlas, if it is observing, knows that something has changed here.
In a sense, the worst-case scenario is not simply observing us, but assessing our potential. Observation is rarely passive. It often leads to judgment. If probes like Atlas are scattered throughout the galaxy, observing nascent civilizations, their purpose might be to determine which ones are significant, which are destined to survive, which will be ignored, which will be silenced. In that case, the galaxy's silence would not be an absence of something, but a consequence. Civilizations arise, observers record, judgments are made, consequences follow. If so, Atlas is not simply observing us, it is judging us. And by what criteria, we cannot know.
Knowing that we are being watched changes the way we think about ourselves. We often imagine that one day we will reach out and become the observers ourselves. But if Atlas is real, we have already passed that point. We are not the first.
We are not the explorers. We are the explored. To acknowledge this is to acknowledge that our history may already be part of someone else's archive.
What we think of as progress, our telescopes, our radio waves, our satellites, are little more than blips recorded by a passing probe. If it is watching, then we are already part of a data set far older and vaster than our own.
And what will that data set show? From Atlas's perspective, the Earth is unstable. Our atmosphere is undergoing rapid change. Carbon dioxide levels are skyrocketing. Methane is rising. Ozone is shifting. In a geological instant, our planet has been transformed.
To an observer, this may not seem like progress, but like crisis. He might see its species changing its environment at a dangerous rate, destabilizing its climate, threatening its biosphere. To us, this is ecological anxiety.
To an observer, it might be evidence that the species is out of control. If he is observing, he might already see us as a civilization on the brink.
The uncertainty here is the most frightening, because we cannot know what he sees, and we cannot know how he interprets it. What looks like pollution to us might look like technology to him.
What looks like crisis to us might look like potential to him. We do not know whether he sees danger or opportunity, threat or promise. We cannot know because we cannot step outside ourselves. We can only imagine his promise.
And in that representation lies fear, because if Atlas is observing, his judgment is invisible. He does not announce himself. He does not tell us what he sees. He only silently watches as we reveal ourselves. The worst-case scenario is not an invasion.
It is a triviality that Atlas watches and sees us clearly, but concludes that we are unimportant, that it registers us as one of many, destined to rise briefly and fall like others before us.
That our signals and our industry are not unique, but typical. Just another line in a record stretching back billions of years. The knowledge that we are ordinary in the eyes of the observer is more unsettling than the fear of attack, because it tells us that we do not matter.
We are not the beginning of the story. We are a footnote in a story already written. And yet perhaps it is worse that we matter.
If Atlas sees us not as ordinary, but as a problem, as noise in a galaxy that prefers silence, then its judgment may not be passive. It may not act itself, but it may signal others or trigger systems that we cannot perceive.
The galaxy may enforce rules we do not know, rules we cannot break without consequence. If it watches and sees us as breaking, then our very visibility may be our undoing.
The fact that we are only now noticing Atlas may itself be part of a sequence. First we become visible, then we are observed, then decisions are made. As Atlas moves away, disappearing into the distance, we are left with this question.
If he is watching, what does he see? The answer is both simple and terrifying. He sees everything. He sees a living planet with industrial chemistry, radio noise, satellites, and a species that has only just begun to look out.
He sees a world changing too fast, a species loud in a galaxy of silence. He sees enough to know that we are here. Whether that knowledge matters is something we cannot know.
All we can do is wonder, because the observer, if he exists, will never tell us what he sees. When Oumuamua was first discovered, the scientific community responded quickly. Telescopes around the world were trained to track it.
Instruments scanned spectra, and radio observatories listened for signals. The decision to listen, to look for something artificial, was itself an unspoken first reaction. The world did not debate whether to listen, it simply did. This pattern was repeated with Borisov, and again with the three Ayalos.
Each time, humanity responded with the same set of reflexes: observe, measure, analyze, explain. But behind these reflexes lies a dilemma that grows more acute with each new visitor.
If one of these objects were to prove more than a natural phenomenon, if it were indeed a probe, what would humanity's first real reaction be? This dilemma is not only scientific, but also civilizational. Reaction is never neutral, even if it seems passive.
To observe is to reveal ourselves. To track the probe, to beam radio waves at it, to publish our findings, is to acknowledge that we have noticed it. If Atlas were just a comet, this admission would be harmless.
But if it were an observer, a messenger in disguise, our attention would itself be a signal. We are saying we see you. It is a message, even if it carries consequences. Because once you acknowledge a presence, you are no longer invisible to it.
The first question is whether we should respond at all. Some argue that silence is the safest option. If the interstellar object is artificial, then drawing attention to ourselves could expose us. By remaining silent, we avoid provoking action. But silence has its risks.
If the object is watching, then our lack of response could be interpreted as ignorance, weakness, or disinterest. In some scenarios, ignorance may be safety. In others, it may be neglect. A civilization that ignores a messenger may be considered irrelevant. A civilization that responds may be considered willing or dangerous. The problem is that we cannot know which interpretation is correct. The second question is how we will respond if we decide to act. Will we attempt to communicate by sending targeted signals toward the target? Will we attempt to intercept it by launching a mission to study it up close? Or will we limit ourselves to remote observation, hoping to learn without being noticed? Each choice carries risks.
Communication may provoke. Interception may be perceived as aggression, and passive observation may be read as fear. There is no safe option, because safety depends not on what we do, but on how it is interpreted. The interpretation depends on the target, not on us.
Consider the possibility of sending a signal. Humanity has debated active messaging for decades. Some scientists support the idea, arguing that if civilizations exist, they should already know about us. Our radio leakage is unmistakable to anyone nearby.
Others caution that broadcasting makes us vulnerable, exposing our presence to unknown forces. The debate remains unresolved. But with an object like Atlas, the debate becomes urgent. Here is a possible listener, close enough to target directly.
Do we risk sending a message or risk letting it pass by without trying? If we send, we may provoke outcomes we cannot predict. If we remain silent, we may miss the only chance we will ever have.
The first dilemma of reaction is that both choices seem like gambles. Now consider interception. Some have proposed missions to pursue interstellar visitors, fast probes that could catch up with them, photograph them, sample their tails.
Technologically, this is barely within our reach, But strategically, interception could be misconstrued. If Atlas is a probe, then an aggressive approach to it might look like hostility. To us, it would be science. To it, it might be defense.
A response intended to teach might arouse suspicion, yet attempting an interception feels like a failure to exploit the opportunity for direct study. Again, both choices feel wrong. Both have consequences we cannot predict. Even the act of observation is not neutral.
By pointing telescopes at Atlas, watching its every move, we are broadcasting an intent. The object cannot see our instruments, but it can detect emissions, radar pings, radio scans. They indicate interest. Interest is information.
An intelligent probe can infer our level of technology simply from the nature of our observations. It can measure our curiosity, our caution, our readiness. Every act of exploration becomes part of the data it collects. In trying to understand it, we reveal ourselves.
In that sense, we have already responded. The dilemma is not in the future tense, it is in the present. The worst case is when our first reaction matters more than we think.
If probes like Atlas are widespread, if they pass through many systems, then every civilization may face this moment, the choice of silence, signal, or intercept. Perhaps the probes exist precisely to test this moment.
Perhaps the galactic filter operates not through violence, but through judgment. Civilizations that respond in a certain way can be classified as benign. Those that respond differently can be perceived as a threat. It is this uncertainty that makes the dilemma so serious.
We do not know which path will guarantee survival, only that one of them may lead to death. To complicate matters further, humanity is not united. There is no single authority that determines our response. Scientists can decide to transmit a signal, governments can decide to intercept, and observatories can decide whether to listen or not. Our disunity means that any response can be fragmented, contradictory, and confusing.
A probe observing us might interpret this lack of unity as a weakness or as a source of danger, seeing us as divided, unpredictable, and unstable. If our initial response reveals more about us than we intended, our internal divisions could become our greatest vulnerability.
The dilemma is not just about what to do, but about who decides. And what if the correct answer is none of the above? What if the safest course of action is to ignore Atlas entirely, treating it like any other cometary debris?
This strategy, too, has its risks. Ignoring the probe could cause us to miss important warnings, opportunities, or dangers. It could be seen as apathy or blindness. A civilization that fails to recognize what it faces could be deemed unworthy of further attention.
The irony is that every choice, silence, signal, intercept, or ignore, reveals something about us. Even indecision is a decision. The probe does not need our communication, only our behavior.
The worst-case scenario is subtle. Not that Atlas destroys us, but that it records us, evaluates us, and moves on. Our first reaction, whatever it is, will be part of a judgment we will never hear, but one that could determine our future.
Perhaps not tomorrow, perhaps not in our lifetime, but eventually. When a galaxy is filled with observers, every first reaction matters. Each one affects how civilizations are perceived and whether they can survive.
Perhaps Atlas has seen enough.
Our hesitations, our debates, our divided votes, all recorded, assessed, and weighed against criteria we do not know. And so humanity finds itself trapped in uncertainty. Should we speak? Should we remain silent? Should we reach out?
Should we hold back? The truth is, no choice feels safe. Each option exposes us. Each carries a risk of consequence. That is the essence of the first reaction dilemma. It is not a question of our preferences, but a question of survival in a galaxy we do not understand.
And as Atlas passes silently through our system, it leaves us not with answers, but with this question, one we will sooner or later have to face again, whether we are ready or not.
When an unfamiliar object appears in the sky, humanity's instinct is almost always to study it. We point telescopes, build models, write theories. Curiosity is our default state. It has driven every achievement we've made, from fire to space travel.
Without curiosity, we stagnate. Without it, we never grow. Yet, when the object is an interstellar visitor like 3A Atlas, curiosity isn't the only instinct that kicks in.
Along with it, another impulse arises, quieter but just as ancient: containment, the need to protect, to defend, to contain. The two instincts, curiosity and containment, pull in different directions.
And when the stakes are cosmic, the tension between them becomes a dilemma that seems almost impossible to resolve. Containment is rooted in fear, but not irrational fear. It is the recognition that the unknown can be dangerous.
On Earth, when explorers brought microbes to new lands, the results were devastating. Entire populations have perished from diseases they could not fight, not out of malice, but out of contact. History has repeated this warning so many times that it has become instinctive.
When faced with the unknown, safety lies in restraint. Do not touch, do not approach, do not invite risk. The logic is simple. What you do not disturb cannot harm you.
If Atlas carries more than ice, then contact may be a danger we cannot foresee. Restraint means refusing that danger, choosing ignorance over exposure. Curiosity, however, rejects such caution. To refuse to study is to refuse to know.
To hold back is to allow the greatest mysteries to pass us by. Atlas is not just a comet. It is a fragment of another star system, older than Earth, stranger than any specimen we have ever seen.
It would be a betrayal of the very essence of human existence to dismiss such a phenomenon without investigating its nature. Scientists insist that the risks are negligible, that spectroscopy and remote sensing are safe, and that every observation brings us closer to the truth.
Curiosity insists that the discovery is worth the risk. It is why we launch probes, why we explore, why we look to the stars. Constraint may keep us safe, but curiosity is what drives us forward. When these instincts collide, the question becomes urgent.
What if Atlas is more than just cometary debris? What if it is a probe, cloaked, dormant, waiting to be awakened? Constraint says, do not engage, let it pass. Do not broadcast. Do not intercept. Do not provoke.
Curiosity says, if we do not engage, we will learn nothing. We will remain ignorant. We will miss the opportunity of a lifetime. Both sides matter. Both sides are fraught with risk. And the choice between them determines not only how we respond to Atlas,
but how we will respond to all interstellar visitors. Humanity stands at a crossroads where the cost of inaction can be as high as the cost of reckless action.
Risk and opportunity are intertwined, forcing us to seek a balance between protection and learning. The choices we make now will determine our future in space and how other civilizations will perceive us.
The opportunity to study Atlas could give us invaluable knowledge about the composition of the cosmos, the existence of extraterrestrial life, and our place in the universe. But on the other hand, careless behavior could draw unwanted attention to our planet and threaten our existence.
We must remember that our actions in space will have far-reaching consequences, and we have a responsibility to be wise and thoughtful. We face a difficult challenge to find a middle ground between curiosity and caution to ensure our future in space and not miss the chance for great discoveries.
The dilemma becomes even more acute when we look back at human history. Our greatest breakthroughs have often occurred when curiosity overcame fear. We have crossed oceans, climbed mountains, sent rockets into orbit. Each time, the risks were enormous. Each time, the unknown loomed. But without these risks, there would be no progress. Limitation would keep us safe, but it would also keep us small. Human history is full of examples where the desire for knowledge and discovery led to great achievements.
New lands, scientific discoveries, technological breakthroughs. All this became possible thanks to the courage and curiosity of our ancestors. They were not afraid to take risks, explore the unknown, and overcome difficulties.
It is thanks to them that we live in a world full of opportunities today. However, history also teaches us that curiosity should be wise and cautious.
We must not forget about the possible risks and dangers that may await us on the path to new knowledge. We must carefully analyze the situation, assess the consequences, and make balanced decisions.
Only in this case we will be able to avoid mistakes and achieve success. We must remember that curiosity is a powerful engine of progress, but it must be directed in the right direction and combined with caution and responsibility.
Otherwise, it can lead to undesirable consequences and even a catastrophe. Therefore, before taking a step into the unknown, it is necessary to carefully weigh and think everything over so as not to harm yourself and others. The same pattern applies now.
If Atlas is harmless, then constraint leaves us in the dark. If it is dangerous, then curiosity could put us in danger. The problem is that we cannot know which is true until it is too late. Worst-case scenarios exist on both sides.
If we choose curiosity without caution, we may provoke or expose ourselves to risks beyond our imagination. A scent signal could attract attention. An interception could be misinterpreted as aggression. A dust analysis could contain seeds we cannot control. Unchecked curiosity becomes vulnerability.
But if we choose constraint, we may miss warnings, overlook threats, or miss opportunities to understand our place in the galaxy. We may allow probes to observe us without even realizing it, sacrificing knowledge for caution. Unchecked constraint becomes blindness.
The balance is fragile, and the consequences of tipping too far in either direction could determine our survival. Humanity is facing a difficult choice that could affect our entire future destiny. We must remember that any decision we make now will have long-term consequences.
Therefore, it is necessary to carefully weigh the pros and cons in order to avoid mistakes and not miss the chance for great discoveries. We must be prepared for any scenarios and act wisely and responsibly to ensure our future in space and not expose ourselves to danger.
Only in this case will we be able to succeed and avoid a catastrophe. It is necessary to remember that our curiosity should be directed for the benefit of humanity and not for its destruction. These tensions are exacerbated by our disunity.
Humanity is not one voice, but many. Some countries may insist on aggressive exploration, while others may insist on cautious containment. Private groups may act independently, sending signals or launching missions, regardless of consensus.
Disagreements and contradictions between countries and organizations create additional difficulties in decision-making. Each has its own interests and point of view on how to respond to the appearance of Atlas.
As a result, instead of a united front, we see disparate actions that can lead to unpredictable consequences. International dialogue and cooperation are needed to develop a common strategy and avoid mistakes.
We must remember that only together can we overcome all difficulties and ensure our future in space. Disagreements and contradictions must be put aside when it comes to the survival of humanity. We must learn to compromise and work together to achieve common goals.
Only then can we succeed and avoid catastrophe. It is necessary to create an international organization that will coordinate the actions of all countries and organizations involved in space exploration. This organization must have the authority to make decisions and control their implementation.
Only in this case will we be able to ensure a unified approach and avoid chaos and confusion. Curiosity and restraint are not abstract concepts. They are shared between cultures, governments, and individuals. A probe passing through our system does not encounter a single species.
It encounters fragmented impulses, some seeking knowledge, others seeking fear. To an observer, this division may be more revealing than our choices themselves. It may show us as indecisive, contradictory, unpredictable.
The fragmentation and contradictions in human society create additional difficulties in determining a strategy for contact with extraterrestrial civilizations. Different countries and organizations may have different interests and goals, which may lead to unpredictable and dangerous consequences.
International dialogue and cooperation are needed to develop a unified strategy that takes into account the interests of all parties. It is important to remember that our actions will be judged by other civilizations, and our future in space will depend on how we present ourselves. We must demonstrate our ability to cooperate and make reasonable decisions in order to gain trust and avoid conflict. Only in this case will we be able to establish peaceful and mutually beneficial relations with other civilizations and ensure our future in space. It is necessary to create an international organization that will coordinate the actions of all countries and organizations involved in space exploration and establishing contacts with extraterrestrial civilizations.
This organization must have the authority to make decisions and control their implementation in order to avoid chaos and confusion. Unpredictability is dangerous in any encounter. The possibility that Atlas is a natural object further complicates the dilemma.
If it is just ice and dust, then containment seems like a futile precaution. If it is something more, then curiosity seems foolhardy. But this ambiguity is constant. We cannot resolve it with certainty. Each interstellar visitor will force us to make choices without answers.
Explore or defend. Risk knowledge or risk ignorance. The paradox is that both options seem wrong and both seem necessary. Humanity always faces the unknown when it comes to new discoveries and contacts with extraterrestrial civilizations.
It is impossible to predict all the consequences of our actions, and we must be prepared for all scenarios. It is important to remember that any decision we make now will have long-term consequences, and we must carefully weigh the pros and cons to avoid making mistakes.
We must be prepared for the fact that our curiosity may lead to undesirable consequences, but we must also not give up the opportunity to gain new knowledge and expand our understanding of the universe.
It is necessary to find a balance between curiosity and caution in order to ensure our future in space and not put ourselves in danger. Only in this case can we succeed and avoid disaster.
We must remember that our goal is not only to gain new knowledge, but also to protect ourselves and our future. Imagine the consequences. If deterrence were dominant, humanity might adopt a policy of non-interference with all interstellar objects, refusing to actively explore them, ignoring anomalies, letting them pass unchecked.
This would preserve safety, but at a high cost. We would lose data that could change our understanding of planet formation, of chemistry, of life itself. We would deprive ourselves of the opportunity to confirm or deny suspicions about probes.
We would live in willful blindness, safer but smaller. Curiosity would fade, and with it, the driving force that defines us. Now imagine the opposite.
If curiosity were dominant, humanity might decide to investigate every visitor, to pursue them with probes, to broadcast signals in their direction. The risks would be considerable.
We might expose ourselves to dangers we do not understand, to warn observers who prefer silence, to provoke responses we cannot foresee. Knowledge will increase, but so would vulnerability. Humanity faces a choice between two extremes, each with its own pros and cons.
Containment can provide security, but it can also lead to stagnation and loss of opportunities to gain new knowledge. Curiosity can lead to discoveries, but it can also put us in danger.
It is necessary to find a balance between these two extremes to ensure our future in space and not put ourselves in danger. It is important to remember that any decision we make now will have long-term consequences, and we must carefully weigh the pros and cons to avoid making mistakes.
We must be prepared for any scenario and act wisely and responsibly to ensure our future in space and not put ourselves in danger. Only then can we succeed and avoid disaster.
Curiosity without restraint can lead us into traps that we do not recognize until they snap shut. It is important to remember that any action we take in space may have unforeseen consequences, and we must be prepared for any scenario.
It is important to be cautious and not take rash steps that could put us in danger. We must carefully analyze any information we receive and not trust everything we see or hear. It is important to remember that our goal is not only to gain new knowledge, but also to protect ourselves and our future. Curiosity should be aimed at the benefit of humanity, not its destruction. We must strive for knowledge, but not forget about safety.
Only in this case will we be able to succeed and avoid a catastrophe. It is necessary to create an international organization that will coordinate the actions of all countries and organizations involved in space exploration and establishing contacts with extraterrestrial civilizations.
This organization must have the authority to make decisions and monitor their implementation in order to avoid chaos and confusion. The focus is on the danger that we may fail to recognize the moment when we shift from courage to recklessness.
The truth is that neither instinct can be abandoned. Restraint and curiosity must coexist, but the balance between them is fragile. Each visitor forces us to weigh them again, to argue again, to decide again. Atlas is just one example, but it exacerbates the dilemma.
Its anomalies make it impossible to ignore. Its ambiguities make it impossible to resolve. We cannot restrain without questioning. We cannot question without risking. The two are inseparable, and that is what makes the dilemma so difficult.
The worst-case scenario is that the galaxy itself is built on this tension, that every civilization that survives faces the same choices, the same risks, the same debates. Perhaps the silence we hear is not an absence, but an aftermath.
Civilizations that chose curiosity and were destroyed, or civilizations that chose containment and disappeared into oblivion. Perhaps survival lies in finding a balance between the two, a balance we are only now beginning to test.
If so, Atlas is more than a comet or a probe. It is the catalyst for our first real test, forcing us to confront instincts older than ourselves, instincts that could determine whether we endure or perish.
And so we watch. Atlas torn between curiosity and fear. We measure, we ponder, we debate. Our curiosity drives us, our restraint holds us back. No one wins, no one loses. The object moves on, silent, indifferent to our debate.
It does not reveal whether curiosity or restraint will save us. That choice is ours alone. And it will not end with Atlas. Every interstellar visitor will reopen the dilemma. Every anomaly will reignite the tension. Every silence will force us to choose again.
Containment versus curiosity is not a temporary conflict. This is the condition of existence of a young species in a galaxy we do not understand. Ever since Oumuamua first passed through the solar system, speculation has revolved around a single, nagging question.
What is the worst-case scenario? Each interstellar visitor has brought us closer to that question, and with 3 Atlas, the weight of that question feels heavier than ever.
We ask it as if there will be a single answer, a clear and terrifying outcome that we can point to and prepare for. But the truth is more complex. The worst case is not a single event.
It is not an invasion or destruction or even extinction alone. It is a set of possibilities, layered and intertwined, each unsettling in its own way. Each points to a universe very different from the one we want to believe in. To ask what the worst case actually means is to admit that it may already be happening, and that we may already be part of it.
One version of the worst case is simple. Atlas is artificial, disguised as a comet, and is watching us even now. If true, the worst case means that we are not alone and that we have no control over this discovery.
We are being watched, catalogued, and judged without our knowledge or consent. The implications go beyond curiosity. To be watched is to be vulnerable. It means that another intelligence already knows who we are, what our world contains, and what stage of development we have reached.
In this sense, the worst case means that we are already known, and knowledge is power. The other version of the worst case is even darker.
That Atlas is not just an observer, but a containment mechanism, that it represents the reality behind the silence of the galaxy. In this perspective, every emerging civilization is marked, monitored, and perhaps restricted. Never allowed to expand freely, never allowed to upset the balance of silence.
If so, then the worst case means that we live not in an empty galaxy, but in a controlled one, a galaxy shaped by rules we do not know and cannot break. Our future will not be our own doing.
Our fate will already be constrained by forces older and stronger than we are. There is also the possibility that the worst case has nothing to do with intent and everything to do with chance.
Atlas is natural, but its anomalies show how little we understand about survival in space. If a body can survive billions of years in the chaos of interstellar space, then perhaps life itself is far more fragile than we realize.
Perhaps we are rare not because intelligence is rare, but because resilience is rare. In this interpretation, the worst case means that the galaxy is indifferent, hostile, and empty. Atlas survives where life cannot. It is a reminder that matter endures, but mind does not. Knowing this allows us to see our own vulnerability reflected in its trajectory. Another level of worst-case scenario comes from biology.
If panspermia is real, then every comet could carry the seeds of life. But if panspermia is deliberate, if probes like Atlas are distributing biological organisms by design, then the worst-case scenario means that our world is not ours.
From this perspective, the worst-case scenario is not death, but manipulation. That our existence is not an accident, but a design we cannot see, carried out by relics drifting in the darkness. Atlas becomes the gardener's tool, and we're the garden.
The horror here is not destruction, but the denial of agency. We are no longer the authors of our own history. We are chapters in someone else's. There is also the subtle worst-case scenario of insignificance, that Atlas is artificial, that it does observe, but its conclusion is simple. We do not matter, that our species, our signals, our industry are just a data point in a record already crowded with others. To us, the discovery seems monumental. To him, it may seem routine.
The galaxy may be filled with life that arose and fell long before us. Civilizations that shone brighter, spread farther, and disappeared more completely. Humanity may not even figure prominently in the comparison. The worst-case scenario here is not threat or manipulation, but rejection.
That we are not important enough to matter to the passing observers. That our existence is not special at all, but ordinary. Yet another possibility takes the idea of routine even further. What if Atlas is not unique, but one of many?
What if probes are constantly passing, all cloaked, all watching, all recording? Then the worst-case scenario means not that this is extraordinary, but that it is normal.
That we live in a galaxy where surveillance is constant, where every system is catalogued, where every civilization is observed from its first sparks to its final silence. The presence of Atlas would then be not a revelation, but a confirmation.
It would mean that the worst-case scenario is not a future possibility, but the present reality of the galaxy we already inhabit. The human mind resists these possibilities because they rob it of the illusion of control.
We like to believe that the future is in our hands, that exploration is where we begin, that discovery is where we claim to be. But the worst-case scenarios offered by Aedelus tell us otherwise.
They tell us that our future may already be decided, that exploration may already be mapped, that discovery may have been made by others long before us.
They tell us that our role may not be to explore the galaxy, but to be explored by it. The worst-case scenario is not just what Atlas might be, but what it says about us, that we are late, that we are ordinary, that we are not in control.
This does not mean that disaster is inevitable. The worst-case scenario is not necessarily an apocalypse. It may be slower, quieter, more insidious. It may mean that humanity continues, but never expands beyond certain limits, never moves beyond containment.
It may mean that we expand, but only along paths already marked out for us, unaware that we are following designs that are not ours. It may mean that our biology carries the seeds of other civilizations.
That our history is part of a cycle older than our species, that our choices matter less than we think. The worst-case scenario need not end in fire. It could end in silence, and silence is, in its own way, more frightening.
What makes this question unbearable is the fact that we cannot resolve it. Atlas will pass. It will leave behind data, numbers, spectra, documents. It will leave behind debates, suspicions, and fears, but it will leave behind no certainty.
We cannot know whether it is natural or artificial, whether it brings life or death, whether it observes or ignores. Uncertainty is constant, and this uncertainty itself is the essence of the worst-case scenario. Never knowing, always doubting, always suspecting, but never proving.
In this world, the number of unexplained phenomena grows with each passing day. Mysterious visitations and ominous silences multiply. Each such event becomes a catalyst for new debates, heightens tensions, and expands the boundaries of possibility. But despite all this, only an oppressive uncertainty remains.
The galaxy remains silent, but in that silence all the fears of humanity echo. The worst-case scenario is not what Atlas represents, but what it makes us realize about ourselves. We are too young, too limited, too fragile to ever know the truth.
And so Atlas continues on its way, leaving behind only a faint trail of light that fades into the distance. Perhaps it is just a comet, or perhaps a probe, or even a ghost.
We are not given the chance to know, and perhaps we never will. This scenario paints a picture of a world where lack of knowledge and certainty becomes the norm, and humanity is forced to live in a state of constant search for truth, knowing that silence may be the only answer it will ever receive.
The worst-case scenario doesn't really mean that we are doomed, but that we are forever in limbo, where there is no certainty, no ignorance, no safety, no doom.
We are simply floating in uncertainty, trying to find answers in the silence, knowing that this silence may be the only answer we will ever get. Imagine a situation where humanity stands on the brink of the unknown, not knowing what lies ahead.
It is not collapse or the end of the world. but rather a state of perpetual uncertainty, where it is impossible to draw firm conclusions. We cannot be sure of our safety, but we are not doomed either.
We are simply stuck somewhere in the middle, in a precarious state where the truth eludes us and the answers to our questions are lost in the silence.
In this state, we continue to search, hoping to find some clue, some hint of truth. But we realize that perhaps the only thing we will get in the end is silence.
This silence may be the most terrible answer, because it leaves us alone with our fears and doubts without any hope of resolution. So the worst-case scenario is not a catastrophe, but a state of constant uncertainty, or humanity is forced to live with questions that have no answers and in a silence that may never be broken.